Okay, sorry, Space News is running a little bit behind schedule today, but we should be good. How's everybody doing? Everybody doing well? Let me bring up a new tab. We'll get the links ready to go. It is October 22nd, 2024. Today is Tuesday. Just Tuesday. Yeah, that's it. Bracker, you just woke up. Oh.
Discovery, go at throttle up.
All right, I got to transfer the links. Once again, these links are from Dr. Mr. OP Creeper, who's a gentleman and a scholar. Thank you for helping me so much lately, Creeper. I do appreciate it. Makes this go very swimmingly. Very smoothly, very swimmingly. Very cash money. Factorio addiction is kicking in. Dude, I am trying as hard as I can to not do that. But the temptation is there. If ever there was a time. If ever there was a time. I kind of want to. But I know I shouldn't. You played it for 14 hours yesterday. I can't, dude. I can't. I know. That's what I would. That's what's gonna happen. Me, dude. Okay. Anyway, welcome to Space News. Let's see. Let me just rifle through these links real quick. Okay. That can go over there. Let me just get some other stuff here. There is Starship news, obviously. Just wait until we have a Mars colony and we could say, today is Friday in Chrysi Planitia. All right, so I'm trying to make sure that we... Yeah, there we go. I'm trying to rope all the Starship stuff to the end. And we'll go through everything else on the way. All right, cool. Think I got everything. Why is the booster catching on the stream behind you yet? Oh, give me a second. I'm gonna try to see if we can. Hired, if you're out there, I need access to that Google Drive to get at those GIFs. Sorry about this. We're dead airing the stream, which is not cool. But just want to make sure we're all clear. What's up? Okay. Yep. I sent a request and it says, "Hey, it's me, your friend EJ. Please help. My stream is very sick." It's not. I'm the one that. Anyway. Okay. Catch needs the center spot. Yeah, Raiden. Yeah. Adrian's, I'm good. I'm good. How are you? G, how you doing? Mike, what's going on? All right, let's do this. So, check this out. We're going to start with some Starlink news. Starlink is now live on a 777 for the first time and will soon be available for all passengers flying on Qatar Airways. Qatar Airways, yeah, has Starlink on it, joining the cadre of airline companies that have Starlink on it, which is okay. That's pretty good. There's a accompanying video. Let's see. Yeah, that's definitely a 777. That's a 777 interior. Dude, that's wild. What's the autopilot configured to? Can we see what heading they're on? Nah. Nah, we can't.
In the cockpit.
They do have the autopilot on, though. I think, where's the AT master? Or the AP master? I think it's that switch over there. The resolution. No, turn it up. Ah, crap. Can't do it. They're heading that way. Cool. Didn't Viasat 3 Americas completely fail? Yeah, it did. That's weird. All right, cool. So Starlink is on Qatar Airways now. I don't know what the total count of airlines that use Starlink is now, but it's definitely getting up there, which is pretty rad. Okay, so download. Are you a flight sim guy? PMDG has a fantastic 777-300ER for flight simulator. Yes. Yeah, I do play flight sim, just not as much as you might think. Hang on. I'm just gonna give me a second. Yes. Hired, whose footage is this? Is this Every time I go down for a break and our Wi-Fi dumps around 30 watts, I just lose it at Viasat every time. Dude, I have had a spotty experience with Viasat. SpaceX and NSF, so yeah, I was gonna say this looks like D's footage. That's good footage, but we gotta put one up there. Hold on. Give me 1 second. It's all rocket noises. Always has been. Oh, hey, get back here. That's what I want. That's the one we need. Right there. Give me a second. We're going to upgrade our mission screens as a special episode of this space news. Now, Hired, here's the thing. Will it work? Uh. Do you guys hear this? Do you guys hear this, the audio from that or no? Yeah, I'm going to go ahead and guess that you do, but I don't. So I'm going to shut that off. And yeah, you guys hear the audio from that, which is good. That's nice. So let's just let's just crop this up. Hired, thank you very much. Just going to crop this up in here. There we go. Yeah. All right. All right. That's pretty sick. All right. Give me 1 second. We'll get that screen going. Actually, we gotta crop this one just a little bit. Let's go up with it. There we go. That's oh wait, no. We gotta go up again. Top the screen. There we go. Yeah. All right. Are we centered? Yeah, look, now it's like beautiful 16:9. Look at that. That's great. I don't like change. Oh, there's a new video in the back. There we go. Hey, all right. That's super sharp, Hired. Thank you for doing this. All right. Yeah. Yeah, this is the next one that we want. Let's cut that, put that over here. Yeah. Yeah. Okay. So, hang on, headphone users again, it's going to blast the audio one more time. Oh. Yep. It only blasted it for a second. It was only for a second. It's fine. There's full 16:9. So you just gotta take this, put this over. No. Hmm. We're just making some modifications, guys. There we go. There. There. There it is. How's that? Pretty good. You know what? You know what? We got to add one more. We gotta add one more. There needs to be one more. Hired, thank you for getting this video in MP4 format. I do appreciate it. Watch out for the sound again, guys. Yeah, once again, headphone users, just turn it down, just in case. Yeah, there we go. All right, should be good now. Yeah. Just get rid of that Falcon 9 launch and let's make this a little bit smaller right there. There we go. Oh, yeah. Oh, yeah. Look at this. Yeah. All right. Now we're good. There we go. Hired. Thank you very much. Turn it up, Roger. How's that? We got some new screens. There's some pretty good stuff going on here. Some pretty good stuff. No more NASA clips. I still got the SLS core over there, and my shuttle is not going nowhere, okay? If you put all of those up permanently, there's zero chance I'll pay attention to anything you say. Ah, crap. Ooh. Ooh. Oh, there is one more thing. There is one more thing before we finish the rest of space news. So I may or may not have I may or may not know people. You know, so I may or may not have gotten this picture that you really can't get anywhere else. You know. So yeah, there might be you know, it might have background sooner rather than later. Maybe. We'll see. Not anymore now that yeah. Yeah. May or may not have one of my buddies go and take a picture of that. Anyway, back to space news. You know what? We just need to make this just a little bit. A little bit smaller. Oh no, it clouds up the logo. It doesn't look right. Center screen stays nice and big. Yes, it's our picture now. You need a short clip of your reaction to the booster landing on the small monitor screen. No, I'm good. Where's Starliner? Yeah. Can we get floating Jeb like one of the old logos? I'll think about it. I think about it. Okay. Yeah. No, this feels right. This feels good. So I missed space news time. Did you miss the part where I said let's get to the rest of space news like 15 seconds ago, or was it delayed? Rain. Do I see Starship under that SpaceX logo? Did you get a Mechazilla shirt? Maybe. Maybe I did. That hurts my neck a lot. Yeah. Yeah, maybe we did. Why mail space news? You serious? I just told you that a moment ago. All right. So, let's see. The next bit of news we'll go through the lightning round. So, this is coming from Stephen Clark. Status report from Tim Larson, Europa Clipper Deputy Project Manager, a little more than a week after launch. All the subsystems are performing well. Everything is green. Everything is healthy. Everything's functioning as expected. Spacecraft is power positive. Good news from Europa Clipper there. Good stuff. Excellent. If you missed the first part of space news, the only thing that you missed is that Starlink is live with Qatar Airways, joining a bunch of other airlines that are carrying Starlink now, which is insane because, yeah, Starlink is turning out to be lucratively profitable. So, this next bit's coming from Stennis Space Center, keeping it cool. NASA's Fred Hayes test stand team conducted a planned flame deflector water flow flush on October 22nd, following the recent completion of upgrades to the high-pressure industrial water facility's underground piping network. The flush, a periodic procedure to ensure system functionality and performance, involves flowing 150,000 gallons or more per minute from the high-pressure industrial water facility to the stand. It also continues stand preparations for testing RS-25 flight engines for use on future Artemis missions to the moon and beyond. All right. Let's see what we got here. Water. Yeah, that's pretty cool. But what about the fish? Yeah, what about the fish? It's a big test stand, man, and that's not even the biggest one they got down there. Run your kids through that with a bar of soap. They'll be clean in seconds. Nice. That's cool. I like these pictures. They really do show the size of the A2. The A2 is not even the biggest one, but that is a monster of a test stand. It looks like something we'd make in Satisfactory, which is pretty rad. People charge good money in cheap theme parks for that. Yeah. Okay. Nice. All right, the next one's coming from Johnson Space Center. NASA's SpaceX Crew 10 patch was thoughtfully designed by the quartet themselves. McLean, Ayers, Onishi, Peskov. The 10-sided patch has the Roman numeral X in the center with a dragon, also the capsule's namesake, with wings out in full flight to represent the 4 professional pilots who make up the crew. The red, white, and blue stars are the flag colors of each crew member's home country, and the brightest stars represent the crew's closest family members and support system. Cool. Yeah, it's a pretty sweet patch. Well, let's see. We have 2 Americans, a Russian, and a Japanese. So yeah, red, white, and blue. Yeah, that makes sense. Cool. All right. Sweet. This next bit of space news is coming from Firefly. Talk about under pressure. Our MLV development tank went through the ringer and passed full flight load testing. Using our newly built structural test stand, the propellant tanks were cryogenically loaded, pressurized to maximum operating levels, and applied with the limit axial load. Congrats to the design, build, and test teams on another MLV milestone. It's a gigantic can crusher. Yeah, axial load. So the long axis of the vehicle. So basically, what this test stand is designed to do, it's designed to fill up the MLV fuel tank with fuel and oxidizer, or but they're probably not going to do that. They're probably going to use liquid nitrogen. Liquid nitrogen is a good approximation. So they fill up the liquid fuel and oxidizer tanks with liquid nitrogen and then crush the thing. See up there? That pulls down on the tank and tries to induce a compression load, which is pretty cool. Sometimes you ideally didn't do your homework right if this happens, but sometimes it does pop. Pressure down on me, pressing down on you. That herp a derp. Can crusher, but bigger. Yeah, that's right. Did you hear that Duracell are sponsoring a DR zone in Vegas? Since Starliner got sent to the backrooms, Crew 11 is targeting summer of 2025. NASA will review the crew members tomorrow. Yeah, hope Xena and Stephanie get the seats. They absolutely will.
Discovery.
True
go and throttle
Ends.
up.
8-month resub. Thanks for the content and knowledge. Cool. Yeah, no problem. Thank you for subscribing for 8 months. Pretty awesome. Okay. There is not a lot in the news cycle today, guys, but we are targeting a Starlink launch, Starlink Group 6-61, which should be in about an hour and 40 minutes. Hour and 42 minutes. So that's going to be a little bit later tonight. It's currently targeting 7:48. It's 6:06 where I'm at. So, yeah, about 2 hours. Hey, I had it right the first time. An hour and 42 minutes. So the rest of space news should, yeah, these 5 tabs should be for the rest of space news. So check this out. So these pictures are from Interstellar Gateway. I'm not too familiar with these dudes, so I'm not going to show these pictures for too long. But those are pictures of the Haas Ridgewind, and under that blue tarp is something that you probably didn't think you would see coming back. Actually, that one goes over there. But Haas Ridgewind is the vessel that actually is a deep sea recovery, well, kind of a contracted deep sea recovery vessel that actually brought back parts of Booster 11 after it crashed into the ocean intentionally. And it looks like Haas Ridgewind was out getting the hot staging ring. And that's exactly what it did. That was right when I started the stream this afternoon. Starbase Live from our buddies over at NSF. Actually, like, they got it. That, it looks to be pretty damn intact, too, from what I can tell. Which is very interesting considering it made a sonic boom, but it looks like it decelerated enough to mitigate any damage during splashdown. We theorize that this is most likely because the hot staging ring has a really low ballistic coefficient. Basically meaning it's a big surface area and not a lot of mass. That's not exactly what ballistic coefficient is, but close enough. And that should have been, that's enough to slow it down. It looks to be pretty damn intact. There's also this news on export control. The export controls. Yeah, we did cover that already. So yeah, I'm not too worried about that. RJ, what happened to the SpaceX oil rigs? The SpaceX oil, they scrapped them. They sold them. They scrapped a good bunch of parts off of them and then sold them. I presume that's in diveable depth. Well, clearly, I mean, Hokie, this is close enough to shore that you can see them. The hot staging ring came down after boost back burn. or it separated from the from Super Heavy after the boost back burn, so it didn't land that far offshore. This camera that NSF shot this with is on solid ground. It's on terra firma. Yeah, I know. I was there. So, is it diveable depth? Yes, absolutely. And I know you knew that. I was just saying it to clue other people into the conversation. Cool video from Cutter. Already looked at it, Baron. They sold the oil rigs for scrap. They wanted to focus on their current launch sites. Exactly, Snake. Yep. Are they going to stop dumping the hot stage ring eventually? With newer versions of the booster, yes. But you know what I can't believe? That thing is really intact for what it is. Yeah, they have divers, Hokey. Yeah, this is not that far, dude. I mean, how far you think it was off the coast? I mean, you said you saw it come down. Hang on. It's a little bit warm today. I'm going to turn on my fans. Give me 1 second. Okay. How far off the coast would you say? I mean, Google Earth can give us a good kind of understanding. 10 kilometers, maybe? Okay, well, that is, first of all, that's before the horizon. The horizon is 14 miles out. So that means the hot staging ring came down like somewhere over here. It's clearly in the horizon. Like, launch site is right there. So it was probably like somewhere right there. What's the depth at that area? It's 76 feet. Yeah, you can absolutely dive that, dude. Oh, yeah. Dude, where Booster 11 came down over here, Booster 11 came down over here somewhere. Like on the edge of this ridge. Yeah, and I actually asked, like, you know, can like deep sea recovery divers dive to 300 feet? And yeah, actually there's a lot of people that know scuba in the chat, and they yeah, you can go down that deep. Sure. So if that thing was over here, 67 feet deep, oh, absolutely. Yeah. I mean, I saw it falling, but the booster kind of took my attention. Yeah. Give me 1 second. The Satisfactory stream VOD on YouTube is demonetized. I don't know what I'm supposed to do here. Yeah, Ryzen, the hot staging ring is pretty intact. Yeah. We got Latin Autoperf. So stupid. I have that thread already open, Foz. Do they give the reason? Melody or lyrics from Halo? The reason is just Halo. That's it. Pretty sure Latin Autoperf does not own the copyright to the Halo in-game music. I'm pretty sure that's Microsoft. So, how are these people not in jail yet? Teething problems with the YouTube channel. What are you going to do? In other news, water is wet. So yeah, okay, you could definitely dive. On the center screen, there are some pixels on top in the middle. There are no more pixels on top in the middle. I don't know, Aqualexa. I don't really care. There's no way. Yeah, somebody's just auto-claiming my videos because they suck. Because people are pieces of Oh, to sign in, you need two-factor authentication. Oh, disputing a claim. Now you got to fill out a bunch. All right, I'll do that later. That's not worth it. No. I don't know. It's claiming the opening music, One Final Effort, which is hilarious. Like, that's not your song that you're playing. But whatever. Okay. Anyway, so they got the hot staging ring back. If you're wondering, what the heck that thing is that they just pulled out, it's the detachable piece from Super Heavy. So right now, because this is an interim, so okay, what you're looking at here is a hot staging ring, okay? Kind of a good ways into development, SpaceX decided that they're going to do what's called hot staging, okay? So the hot staging ring is this kind of cheese grater looking thing up at the top. Now, what is hot staging, just in case anybody's wondering? Well, geez, now we have to look at, some footage from Flight 5. Boy, that sucks. Right? Right? That's just that is unfortunate. Hot staging summer. Yeah, all right. So, all right, let's take a look right here. We want this one. All right, so take a peek. I'll show the whole footage first, and then I'll show you where this hot staging ring fits into this whole thing. Just okay. All right. Where's the whole coverage? Do we have a recap? All right, this is good enough. This will work. So, check this out. Hello.
25 UTC. So that coming up, it's going to be 4.
All right, here we'll watch.
2, 1.
So, with Starship, you have Super Heavy, which is the bottom, and then in between Super Heavy and Starship, which is the darker part of this rocket up here, you have the hot staging ring. Now, the hot staging ring allows the second stage engines to fire, Starship's engines, which it has 6 of them. It allows them to fire while the first stage is still burning. So, you stage while your engines are on, okay? Now, you'll see a video of that and what that looks like here in a moment.
Is doing there,
Watch.
Go, no, go.
Is it pin lux? Yeah, I missed it.
We might hear some really good words soon, too. All right.
So watch. If you watch this footage, Starship's engines will fire while Super Heavy's engines are still, or 3 of Super Heavy's engines are still on. See? So look, you got 3 engines on the first stage still active. Now watch over here and watch the lights light up.
Next.
Click, 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 click.
Ship engine
There's
startup.
most engines
There it
going.
goes.
Stage separation. Booster
Stage
prep.
separation. Hot stage.
Okay, so why do this? Why do this? Well, honestly, it's simple. It's really simple. It is the simplest way of staging something ever. You don't need anything to push your second stage away. You don't need something like a pneumatic actuator rod, like what Falcon 9 would use. Falcon 9 has 3 pneumatic rods that push the stage physically away. And you don't have to worry about ullage venting and propellant settling. That's the biggest one. So, I don't know if you guys knew, Starship is kind of large. This thing is carrying a lot of fuel and oxidizer. So you got a lot of methane, you got a lot of oxidizer. If they stage this rocket, so the rocket right now at this point is under acceleration. It's under acceleration. So all the propellants, because it's accelerating against the force of gravity here, all the propellants are settled at the bottom of the tanks, right? Now, if you stage and you shut all your engines off, you're going to go from an accelerating force to a decelerating force momentarily. Basically, you shoot forward in the seats, right? Nobody's on board. Just bear with me there on that one. So when that happens, the propellants tend to slosh around, right? I don't know if you guys can hear that. They'll slosh around. You don't want that. Hot staging allows you to keep your propellants settled at the bottom of their tanks and up, because the first stage never stops firing its engines. Now, don't get me wrong, no one's ever boosted back and landed a hot staging thing. Other rockets that do hot staging are expendable up until this point. I mean, Soyuz is the one that comes to mind. So the hot staging ring keeps things nice and simple. Now, SpaceX on the first flight did not have a hot staging ring. They decided they wanted to add this to keep the staging simple, right? They originally had like a push rod mechanism, but this is way simpler. The ring is just a steel lattice for the most part. That's a lot simpler than some type of pneumatic system to push Starship away. So all they have is the connectors right there, the 3 connectors, where it latches to Starship, and that's it. 3 latches right there and 3 guide rods. Actually, you can't see the guide rods in here, but that's another story. So, way simpler than trying to come up with some type of pusher mechanism and then having Starship vent or fire its RCS to settle the propellants and then fire. This saves you a ton of delta V too. It also is way simpler. Now, because this was retrofitted to Starship's design, SpaceX needs to redesign Super Heavy. So are they going to redesign the entire booster? No. They'll just wait till a newer version. So in the meantime, they installed these hot staging rings on Flight 2, 3, 4, and 5. Right? They installed these things on there. What does the hot staging ring do? Well, if there was no hot staging ring, Starship would be firing its engines into the top of the methane tank first. And then in front of the methane tank is your avionics and grid fin actuators. I don't think I need to say why you don't want to fire rocket engines into those things. So, they added a flame deflector. That's what that is. It's a flame deflector. To push the second stage flames out to the side, like what we saw in the video. See, there's the hot staging ring. So watch. If you watch this again here, you'll see the flames start to shoot out. Specifically, they fire the 3 vacuum engines, so you'll see them shoot out. One shoot out over here and another one shoot out in that direction. Actually, it'll be over here. Yeah, that's right. That's correct. Watch.
Right now, the tower team is doing their go, no go.
Recently subscribed and now seeing your streams. How can you stream so much every day? I've been doing it for a long time, Epic. The fact that they also use grid fins to help flip the booster at staging is pretty tricky as well. Yeah, one of the last things you'll see here is the grid fins turn into position, and they use the flow coming out of the hot staging ring to help actually give some effective moment on the booster to turn it around. Yeah. Epic, how do I stream so much? I don't know. I just do it. I love it. I love what I do. I could sit here and talk rockets every day. I honestly don't have enough time in the day. I could do this all day, every day. I have been for 12 years. Yeah, man. Yeah, it also cooked the grid fins as well. We figured that out. I utilize time dilation.
We might hear some really good words soon, too.
Watch.
All right.
Gotta love what you do. You gotta love it to do this job, Epic. You really do. If you don't, oh, see, there they go. They're turning.
Gorgeous things I've ever seen.
Now watch. See, the flow from the Vector engines, the vacuum raptors, are going to cross the grid fin, and it'll actually it'll help flip
Seen
the
it my
booster.
entire life.
Smart.
Coming up on hot staging
Watch.
next.
Ship engine
There's
startup.
both engines cut off.
Stage separation.
Isn't that sick? That's sick.
Booster.
My favorite part of this is that you can see Starship right there. Look. Oh! You could see 6 engines burning right in the background right there. That's so kick-ass, man. Oh my god. That's awesome. I'm sorry. That's so freaking cool. The grid fins also got toasted. We did Kerbal in real life. Yeah, those fins got instantly warped. Yep, that's right. Watch the fire go through the grid fins. See the grid fins?
There's both engines.
Stage separation.
Uh-oh.
Booster.
Stage separation. Hot stage separation
So.
confirmed.
SpaceX, in keeping with their, you know what? We need data on this, so let's just go fish it out of the ocean. Got the hot staging ring back. Now watch, if we want, the hot staging ring is still connected in this.
Ship under its own power. I'm seeing 6 out of 6 Raptors lit.
They caught the booster.
I got a booster on the way back to me. I'm going to send it to you guys in Hawthorne.
Oh man, that was absolutely.
And we did.
Once again.
Now
once
watch.
Again,
You could see it right there. They jettisoned the hot staging
the
ring.
ship, excuse me, the
That
booster
freaking
is making
ring,
its way
right there.
back to the launch site.
See it?
We are
See this
going
little
to
guy on the
try
look.
and catch it.
There it is. Dude. That thing right there is what they just fished out of the water a couple hours ago. They went and got it. Titanium wouldn't have cared. Yeah, I don't know if anybody's going to cast a titanium grid fin Aldezert that's the size of an 8-foot box on a truck, because that's how big those damn grid fins are. A long bed pickup truck. Those grid fins are the size of the box in Tough Enough in my F-250, which is just like, all right, that's not small at all. How would they find it? Does it have a tracker? They sent out deep sea divers, so downward facing sonar wasps should be able to get it in shallow water.
On the launch
They
tower,
know
the exact
roughly
same
where it
tower
came
that
down.
just launched from just 5 minutes ago.
Okay, to be honest, how much of it is intact? Dude, Yuri, this will blow your freaking mind, dude. Like, no, that's later. Look, this is coming from NSF. This is on NSF Live. I still can't believe this. How is this even possible? Look at it. It's fine. What the frick? Now, you know, you're looking at it like, okay, that's a little ways away. It could be damaged a little bit. Then, watch, it gleams off the sun, and you can see that the ring is intact. Like, what the how is that possible? Wow, reuse it. Yeah. How big do you think the catch pins are? The size of a grapefruit, Sorden. I know that for a fact because I know people. Yeah, they're, I don't know, dude, 15 centimeters at best. What did they explode if it looks intact? What do you mean, Chris? Might as well see if they can reuse it. I don't know. I mean, I'd have to see it up close, dude. So, here's the thing. I started to think, how the heck does that thing? So, once again, see the dude, like, there's a dude for scale. There's the 2 dudes right there. This is pictures coming from SpaceX. It's only from this ring up. It's only that came back, right? Only that was jettisoned. So from here up, right? I started thinking about this. So, you have a very high surface area exposed to windward velocity, right? It's cup-shaped, right? So, it kind of works like a parachute, almost. And if the center of gravity is actually basically in the center of this thing, which, or even a little bit lower, it actually is going to naturally stabilize with the cone part facing up. It'll naturally aerodynamically stabilize like that, right? Now, here's my theory for how this thing came down intact. And all you have to do is go and look at the shuttle program here. So, let's just do SRB /down. That probably gives us what we're looking for. Here. So the shuttle program brought the SRBs back. They reused the solid rocket boosters, right? Here's a picture of one coming back down. This is not footage that a lot of people see, okay? I'll check it in a second, Hired. So, the SRB would pull its parachutes, but a lot of people wonder, like, why couldn't you do this with the liquid fuel booster? Well, if this was a liquid fuel booster and it crashed into the water, it would get very damaged very quick. The SRB, though, is just a big pipe. Now, because of that, right, because it's just a big tube with basically a nozzle and a throat at the end, right, you don't really need any boost back or landing burn with this thing. Well, no boost back. You don't need a landing burn with it, right? Watch this thing come back down. Now, what the first thing that it's going to do, you have your drogue chute, so your pilot chute, and then your 3 chutes will deploy, but that's still not going to slow it down enough, right? How this thing actually slows itself down the most, or, well, the 3 chutes first and foremost, but how this thing doesn't just absolutely obliterate itself when it comes down into the ground is because there's the nozzle jettison. At the end of the day, an SRB is, once again, a long tube. What happens if you take an empty bottle of water and you dunk it in water? It's going to want to go up, right? If you took a cup, right, a paper cup, and you forced it into a body of water, right, and you let it go, the paper cup's going to be buoyant. It's going to go up. Now, that plays into SRB landings, all right? So full chutes unfurl, etc., right? But that's still not enough to slow this thing down. It's still coming in pretty dang hot. So what the SRB actually does is it comes down with the nozzle, jettison, and the throat basically facing towards the water. When it hits the surface, water gets pushed into the throat. And what happens is it actually repressurizes the SRB. The atmosphere that's in there at this point in time is going to get compressed. And what that is going to do, because gas is compressible, it's going to act like a giant hydropneumatic shock absorber and actually cushion the booster's landing. Whoop. If you look, when the booster splashes down, it immediately stops. It doesn't plunge into the water, right? Doesn't plunge like all the way into the water and then bob right back up. Just kind of watch this with your peripherals almost. The booster just basically hits the surface and stops. Ready? Boop. You see it? It stopped and then it kind of moved to the side, right? What happened is all that air got compressed inside of the combustion chamber of the SRB, and that actually stopped it. It slowed the thing down. It dampened out all of its motion. It also dampened the SRB, because dampen and dampening. When the SRB tilts over, you see all that compressed gas release in this huge cloud shooting out the side. See all that? And now the SRB comes down to rest on its side. Easy peasy. Right? It's basically a gigantic hydropneumatic shock absorber. This actually was not thought of by the shuttle program, believe it or not. Yeah, that's how they were able to get the boosters back intact. And if you tried to do the same thing with a liquid fuel booster, it would not work. It would not work well at all. So, where did they get this idea? This idea came from the Apollo Applications Program, believe it or not. Let me find the right thing, the right infographic here. The Apollo engineers had an idea. Actually, this was a Boeing idea. They had this idea of taking an S1C and being able to reuse it. How would they reuse it? Well, what they would do is they would attach a bunch of parachutes to the back, to the thrust section, right, of a Saturn V first stage. The parachutes would deploy just like the SRB, same idea, only it would deploy it with the forward-facing bulkhead from the liquid oxygen tank facing towards the water. Then the bulkhead, the top bulkhead, would pop off. The forward-facing dome on the S1C LOX tank would pop off, and it would basically do that. And then they would use the buoyancy from the RP1 tank to keep the thing afloat. That's what happens. They got the idea from the Apollo Applications Program, that is. Were the chutes too much mass? No, the Apollo program did not survive long enough for them to do that. To even try. But that's what they wanted to do. The other idea for a reusable S1C was this, which is not necessarily pertinent to subject, but I'm just going to show you anyway, because why are you using sci-fi for the screen above your head? Yeah, sorry about that. I've been really into sci-fi lately with Halo. You think they are studying the clamps as mentioned in that analysis by CSI Starbase? Absolutely, Gary. Every part of, I mean, first of all, Zach's the freaking man. I had an opportunity to work with him a long time ago, and I screwed up because I was too busy. But yeah, Zach's the man. I wanted to get him on the stream, dude. And then he wanted me to do some CSI Starbase stuff because his analysis is dope. But yeah, those plans fell through. It happens. But yeah, Zach's good people. I like him a lot. He's a good dude. Basically, whatever Zach says is mostly, I would agree with whatever he says, dude. He's okay. Let's put it like this. Zach is way smarter than me when it comes to ground servicing equipment and how all the equipment gets set up and design. He's way smarter than me. He has like 3 engineering degrees, dude. That guy is not stupid. Let's put it that way. But yeah, if Zach says it's probably a thing, it's probably a thing, man. I think they're probably looking at every single bit of Booster 12. They probably took a bunch of pictures before they put it on the stack to launch, and now they're comparing those pictures to what it looks like now. You like seriously, just take a picture of it before you launch it, and then it came back and landed, as you can see right as you. Hold up. As you can see right here, it did the whole landing thing. The chopsticks are like, you know. How would the Wing S1C work? It would fly back. They were going to put a cockpit on the front of it, and somebody would actually be flying the SRB or the S1C back. Yeah. The Apollo program was cooking, man. So dude, if it was me, I would take apart every single piece of that thing and compare it to what it looked like before it flew. What's changed? What's changed? Did it change? If nothing has changed, dude, fly it again. And speaking of nothing changing, we will segue to the next topic here. You guys might appreciate this next one. So not only did SpaceX recover the hot staging ring, Booster 13. Basically, while I was on break for space news, Booster 13 rolled to the pad. This is how fast the news is coming at us nowadays. And you know what? I'm here for it, man. That's fine. That's fine. Booster 13 rolled to the pad. This is getting out of hand. Now there are two of them. There you go, Edmana. Yeah, this is where we were headed with the Apollo program had they just kind of kept on going. I think that's somebody's Kerbal build, to be honest with you, but yeah, that's the idea. That was the idea. Yeah, that's from a Hayes Gray art video. Saturn shuttle. That's what they wanted to do. They wanted to take a shuttle external tank and the space shuttle, instead of SRBs on the sides, put a Saturn V first stage below that and have the Saturn V first stage be a shuttle as well. That's what they wanted to do, man. It's, you know what? That's pretty rad. I'm not gonna lie. That's a pretty cool idea. Like, I don't hate it. Would have kept the Saturn workforce around. Yeah, we know that that's probably a good idea. Yeah, we need this, bro. What do you mean we need this? We have this. We basically have this, only SpaceX decided to combine the external tank and the space shuttle into one vehicle. What do you think Starship is, man? They were using narcotics. And man, I'm not gonna lie to you, you need to be tripping to come up with some of the ideas that they were cranking out, dude. You need to be tripping. Like, Haight-Ashbury tripping. Like old Haight-Ashbury, like not whatever it is now. Whatever that is, I don't know what that is. You know what I mean? Like straight LSD, like some of these ideas are just, what? You wanted to do what? What? And Vin's like, I'm already there, man. I love how huge that booster is. Dude, it's so cool. Sounds like a good time. Sorry, I've told you this once, I'll tell you again. As long as you're tripping balls within the comfort of your own home. Have at it, man. I mean, right? Like, oh my goodness. Apollo engineers wish they had Falcon 9, but you know, they would have got their own. Yeah, if they had had the time, dude. Imagine a Falcon Heavy, but it's super heavy. Starship super heavy. Starship super duper heavy. Dude, 3 of these next to each other with a Starship on top. That, first of all, you need 3 catch pads. Second of all right, so what? Third of all, do you even need in-flight refueling if you're going to do something like that? But then again, you'd have to stage 99 engines and get 99 engines to start perfectly, or else it's not going anywhere. Gitai shared another video. Yeah, I told you I had it open. At least I thought I did. Yeah, I did. We could talk more about that. Yeah. And there's also this slide. I'm not sure where that slide came from about Starlink satellites, but you know, we'll cross that bridge when we get to it. For show, Cap, my bad. Oh, all good, man. All good. I know I go fast. I know sometimes it's hard to keep up. You guys are way quicker than me. Don't tell anybody, though. All right, so Booster 13 is already, for Flight 6, is already rolling to the pad, guys. This is going to happen. This kind of proves what I'm thinking. This is going to happen a lot faster than you think. It would be fun to see a super heavy launch with 3 super heavy boosters. Yeah, I'm not disagreeing. Get Nina to set up the staging. She did well with the 99 Luftballons. Oh wait, we can't do that. Somebody might claim my video, even though I played like 5 seconds of music, which could be counted in every way, shape, and form in a 12-hour freaking VOD is transformative. Before the election, Edmana? No, a little ways after. A little ways after. What the heck would the GSE look like for a 99 engine launch? You'd need 3 OLMs stacked next to each other. That would look ridiculous. That's how that would look. Well, 12, you just get that place has changed a lot since you were down there in 2021. Well, you're just gonna have to go back and check it out to see all the changes. Booster 13 external changes. Locks cowbell design changed on the common dome. Yeah, right there. The cowbells are, see, you see them right there? They're a little different. They look more like this. Guess what? I got a fever. And the only prescription is more Starship. I gotta have more Starship, baby. I want you to explore the space. Explore the space. Ship 31 is undergoing tile rework, but won't be nothing compared to how many hours they put into Ship 30. Focused on flap. Next ship fixes the burn through. Agreed. Yep. Yeah, I'd say the middle of November. I actually guessed the 11th of November. If it launches on the 15th of November, I'm going to be pissed because I'm not going to be here. 14th, 15th, and 16th, I'm gone. Which is a problem. FYI, that SNL episode came out 24 years ago. Why are you the way that you are? Damn! The hell, man? Are they going to land Starship or Splash again? Splash, VA. Yeah, yes, Crownless. That's what's going on. All right. Anyway. So, yeah, here's a shot from my buddy LSR, who compiled together a bunch of SBL footage. And SNL hasn't been funny since. Wrecked. Wait a minute. Bum, 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 bum. Bum, 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 ba, 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 bum. Spa, ba, ba, bum. Spa, ba, ba, bum. Spa, ba, ba, bum. Spa, ba, ba, bum. Get the frick up. Bum, 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 bum. Simon Says, get the frick up. Bum, 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 bum. All right. LSR, yeah, I know the dude that made that. Yeah, LSR, it's pretty good, right? Yeah, I know, that guy does pretty good work, only sometimes, though. Seriously, these time lapses are sweet, man. Thank you. It looks like Bender's moon girlfriend. No, that's the damn Crushinator. Damn it, Crushinator. So yeah, 13's already rolling, dudes. 13 is already rolling. We're good. If you missed it, the first test of a variable geometry electric jet engine. What is this, Hermias? Huh. I'll check that out in a second. Is 13 the next one? Booster 13 is going to be for Flight 6, Mads. Yep. Also, follow LSR. He's a pretty cool guy. Doesn't afraid of anything. Does some pretty good stuff for NSF. Just saying. Has SpaceX pushed the plan for IFT6? No, they haven't just Space, but I'm guessing sooner rather than later. They already have the launch license for 6, guys. It's going to happen at basically as quick as they can get a Starship ready. So ship 31. Gonna go quick. They're redoing the tiles. Is tonight Starlink Northern again? I don't know. Because it's booster 13, you hope there's nothing to worry about? There's nothing to worry about. Can you try to do a prediction when you see where you'll see space exploration in 2050 and 2100? What would you like to see? Fusion is the gist of that. Where would I like to see space flight in 2050? Fusion. Fusion attached to an electric propulsion. Yeah, that will get us that's Star Wars, man. Yeah, Star Wars. Is it lifting off at 1313? I don't know. Israel, yeah, fusion is the biggest one. Why? So we have this thing called electric propulsion, okay? And keep in mind, this is very much my opinion. This or nuclear thermal would probably be the best ones. So if we have fusion, so if you have a spacecraft with a fusion reactor in it, so it could be a tokamak, could be a stellarator, pick your form of nuclear fusion. It could be the collidable fusion reactor, which that's the new thing that people are working on, which is pretty rad. That thing is super cool. It shoots, basically crashes like detonation waves into each other. Direct fusion plasma tap. If you wanted to do that, Aqualux, that's fine. But I would prefer solar electric. Solar electric propulsion. Or not solar electric, just electric propulsion. A Hall effect thruster coupled to a fusion drive with xenon gas. That's it, man. Electric propulsion is entirely scalable. The only reason why our electric propulsion thrusters are like this big is because we use solar panels in space. If we were somehow able to get a nuclear reactor up there or fusion or whatever, you could make a bigger solar propulsion module. And if you make a bigger propulsion module, you could scale it. It just depends on how much electricity can you generate. So think about like a gigawatt electric thruster would look like, dude. That would be pretty cool. What's the specific impulse of here? Let me give you an example. Like, all right, so, so a Hall effect thruster, and keep in mind this technology can be scaled up. Hall effect thrusters are able to accelerate their exhaust speeds to between 10 and 80 kilometers a second. 1,000 to 8,000 seconds specific impulse. 8,000 seconds specific impulse. The most efficient we have. So, okay, what's specific impulse? Just in case anybody's wondering. Specific impulse is basically the miles per gallon for your rocket engine, for your form of propulsion. The higher that number is, the higher the miles per gallon. Okay. Our most efficient thing that we have right now is Centaur. Centaur with an RL-10. The RL-10 can make 462 seconds specific impulse. That is the most efficient thing we have. Hall effect thrusters can get to 8,000 seconds specific impulse. We're talking about the difference between like a Ford Model A and a Ford GT. That's the difference. That's the technological leap here. If we can scale electric propulsion in space, and you can, it's very scalable, and you could make like a gigawatt, 1.21 gigawatts electric thruster. You could make something that's about as powerful, maybe like, I don't know, maybe as an RL-10. RL-10s don't make a lot of power. But we're talking 800 times, an 800% increase in a, no, it's actually more than that. We're talking almost 1,000% increase in efficiency here. Meaning going to the moon is easy. And going to Mars is easy. That is like approaching expanse territory. That's Epstein drive territory for efficiency. That's very nice. Or you just shoot plasma out the back too, Aqualex. That'll work too. That'll work too. Why not both? How about, okay, all right. Piss off. New plan. How about we have this fusion reactor thing that we're talking about, right? Direct coupling main propulsion, right? To your plasma drive, your fusion plasma drive, right? Right. Shut up. You, shut up. Listen. With Hall effect RCS. Yeah, that right there is basically a sci-fi ship. That's basically Star Wars. T0 is 848 for Starlink. Balls. Yeah, brachistochrone trajectories, just space. That's what it's called. Yep. Yeah, that's absolutely, yeah, that's a thing. Isfil, that's where I think we need to be. The inner broadcaster would think that it's easy. Be quiet. With the redesign of the Pad B OLM, it looks like it could replace the mobile transporters and just roll. It looks like it could be replaced with the mobile transporters and just roll it out of the way to put down a new one and land a ship. Hobie, I think that SpaceX is going for a mobile launcher platform design with OLMB, and I think all subsequent OLMs are going to do this. I theorized this in 2023, maybe 2023. Before Zach did. But then again, my reason was a little bit different. My reason is because I don't want to see the VAB get abandoned. Because if Starship is successful, that means SLS's years are numbered, I think. And I'm saying that even as an SLS fan. And I would not want to see the VAB get abandoned and be like Baikonur. That would really piss me off. So, in my huge copium, with some huge copium, taking a big hit of huge copium there, I would want Starship to use the VAB. And if Starship is going to use the VAB, making mobile launcher platforms are the best way to do that. They wouldn't be the first ones to do it. MLPs are something that the shuttle used. That's a paper model. Hold on. Give me 1 second. So the space shuttle launch pad wasn't actually, it's not actually the whole launch pad. It's just the pad base. Trying to find a picture that, oh yeah, this picture of Discovery from its first launch, totally Getty images. Oh, thanks, Brooks. Thanks for this picture. Hey, how'd you get inside of the blast detonation area, Brooks? You sure a NASA PAO didn't take this picture from, STS-41? I think it's 41C, Discovery's first flight. You know how I know it's Discovery's first flight? This is the inaugural flight. It has the Centaur G refueling umbilical mounts down there. So this picture is from the early 80s. So it would have been Discovery's first flight. Yeah. Yeah. Oh, yeah, Brooks, you took this picture. Credit to Getty Images. No. I know, Brooks. I watched him take it. Frack, I think you're lying to me. No, he absolutely took that picture. No, it's totally not. It's totally not Discovery's first flight. Yeah, no. Anyway, so, see the mobile launcher platform down there? Yeah, watermarking a NASA public image. That's one part of this future that I don't like. That whole thing right there. I don't like that. You know too much. Sorry. Here, ready? Watch this. Want to see something cool? Let's see if I'm right. Shuttle Discovery first mission. Let's see if that picture pops up. Let's try this. STS-41D. Didn't you already click on the right image? Yeah, that's close enough. But yeah, anyway. Yeah, I knew the exact mission. That's what I'm trying to say. That's what I'm trying to tell you. Yeah. Ooh. Yeah, once again, the dead giveaway is the in case anybody was wondering how I knew that. The dead giveaway is the Centaur attachment. So shuttle was going to use Centaur G. I can't find this exact photo, but I know that's a PAO photo. Because they don't let people inside of the blast detonation area, and they definitely don't let just any old photographer on top of the RSS, the rotating service structure, with a shuttle on the pad. You know why? Those SRBs have fuel in them. That's why they don't allow people near them. The only people that should be there should people that work there, and that's it. But see that right there? That is that's the umbilical arm for Centaur G. Shuttle was supposed to carry a Hydrolox upper stage in it, and that the umbilical would have reached out here and attached to a carrier umbilical plate on the side of the shuttle so they could fuel up the Centaur stage when the shuttle was on the pad. Yeah, that's how I knew it was an older picture. So, moving on. Also, screw Brooks. Screw you, Brooks. You suck. Could that be the name of a NASA PAO? Maybe. It's possible. In which case, Brooks, I'm sorry. But also, screw you. Maybe it's credit for finding the image for Getty, not the actual photo itself. That's exactly what's going on. But also, screw you, Brooks. You jag. I've never met this guy. I'm making a joke. All right, just in case anybody was wondering. All right, so... All right, check this out here. Take a look. So this is Gitai again. This is a company we looked into yesterday, basically using robotic arms to build solar panel towers, and I guess their arms do more than just that. So here, let's check it out. I found it. It was Challenger on STS-7. Why did it say Discovery on the side then, Cat? Riddle me that one. Huh. I've always seen you on NSF, but didn't know you had your own channel until recently. This is an absolutely hidden gem. Thanks, BCR. Right on, man. Dude, excavator. It attached a bucket to it. Did you see that? What was the company called? Giat Orbital? Please, God, don't ever call it that again. It's Gitai. Holy crap. Yeah, that's right. Where does the bucket go? That's right. It goes in the square hole. And look at it. Look at it. It's going to pull its little wagon around. Look at it. It pulls the little wagon. So cute. Bye-bye. Dude, that thing is... That's actually super cool, man. That's the most expensive remote control excavator ever. Dude, that arm just monkey barred off of the lander, and now it's attached to the rover, and it's still powered. Like, and now it's just going to scoop it up. Where does the lunar regolith go? That's right. It goes in the square hole. It's right. It goes in the square hole. That's super cool. That's super cool. Dude, I am a fan. I'm a fan. That's pretty rad, man. Good robot. And look at now, he's gonna pull his little wagon around. Dude, you gotta be kidding me. That's super cool, man. Oh, that's some pretty cool robotic work. That'd be really good for a Mars sample return mission. Yeah, I know. That's weird. That's so cool it made you rotate my chair 3 times and subsequently do backflips. Hell yeah. Hell yeah. This kind of robotics is sweet. We got this kind of stuff in our manufacturing for trucks and cars. Was just working on it today. Right on, Bob. When your kid gets the mini shopping cart in the supermarket. The company that made the electric engine that I sent you. Okay. All right, we can look at that next. There is one last bit of things for Starlink satellites that I probably should have led with the rest of the Starlink news, but we're gonna watch this instead. Now, guys, I'm not gonna sit here and pretend like this probably isn't loud, but it's probably loud. So I'm gonna go ahead and turn it up, and I'm just gonna warn you that it might be loud. It might be loud. Okay, is that fair? Starlink is delayed. Yep, that's right, Kenji. I'm turning it up. So, you know, headphone users, you have 10 seconds to comply. Stop or there will be trouble. It's angry. Oh! Damn! What the hell was that? What the hell was it? What is this? Can I put that on your car? Yeah, you go faster. What the frick? What was that? I feel like I just got hit in the face with a knuckle puck. Wait, can I just... That's right, the thrust comes out of the square hole. Dude, that's awesome! I want to go fast. The screams of the doom followed by the fires of the underworld. This engine will open up a gate into the 7th depth of hell! That's right, the EJ goes in the mass hole. That's right, yeah, that's right. It goes in the square hole. That's freaking sick, dude. Alright, so Astromechanica, a new startup ushering in the electric adaptive age where supersonic electric jets cross the Atlantic. Okay. That's right, new jets for the jet age. Alright, what do we got here?
What's it like being here on the day of first hot fire for the engine after years and decades for you of imagining a system like this?
Oh, I'm not too sentimental. I just wanted to work.
Test fighter in 3, 2, 1.
Oh,
Man's age-old dream of flight becomes a reality.
ooh. This is a little video here. Let's see what we got. I was strolling on the moon one day. Oh, sorry.
Love the smell of jet fuel.
Who doesn't?
My name is Ian Brook. Company is Astra Mechanica, building new supersonic aircraft powered by a new kind of jet engine.
How many flight hours do you think you have at this? Oh, I mean, I've got 1,500 hours. All right, good to go. Santa Rosa Tower, Diamond Twin, November 6-3, Golf Hotel, ready to go, 1-4, like straight out, southeast bound. 7-6-3, Golf Hotel, Santa Rosa Tower, hold short of runway 14, up 3. Go time. 55 kids, really, runway 14, up 3.
That's a diamond, right, dudes? He's twin engine, dude. Got a twin engine cert. Pretty cool.
When you're up here doing this, it's very clear, you know, there's no, like, hard lines between anywhere. This is all just Earth.
I love
being
flying.
up here and seeing this, it puts things in a more correct scale. I think it's like if you the screen for too long, or just like inside a building for too long, this is a version of touching grass. What do you call this? Like touching the sky.
Yeah, baby, touch the sky.
Good for the soul.
Gotta be a jukebox hero. Have stars in your eyes. Be a jukebox hero. Touch the skies. Those aren't the words, or are they?
I'm Matthew Perkins. I lead the electrical engineering and software teams here. We're trying to make a new jet engine that enables supersonic flight in a sustainable, fuel-efficient fashion. What's unique about our engine is that we're splitting it into basically two parts. One is the compressor and propulsive side of it, and one is the turbine and generator side of it. And the way in which we're coupling them together is taking two electric motors. The turbine spins one motor, acts as a generator. The other motor spins the compressor, and we connect the two with basically just like cables and a battery. What that enables us to do is run both of those halves in different operating regimes depending on the speed of flight. So we can optimize the engine to run at Mach 1 just as well as it runs at like Mach 3, which historically has been kind of
that's badass, dude.
Going really fast,
that's so cool.
Efficient, or if it's efficient when it's going really fast, it's horribly inefficient when it's going slow. Our engines should be efficient across the full operating regime, which is the really cool thing about it.
The way this works, we burn fuel in a generator. That generates the electrical power over here. That electrical power
Dude,
is
it's
then
a
used in the
divorced
system, so we're just
turbojet.
testing this
That's
other thing, so
nuts!
this is a really new piece.
Oh, that's so
this
cool!
is sort of the initial cold mode. It behaves just like a turbofan. And then what we're testing today for the first time is we're going to introduce fuel here in the combustor. And that allows the system to behave both as that turbofan cycle and then going past that to be the jet cycle. That combination of low speed and high speed capability and efficiency, it increases the range pretty dramatically over anything that's existed
Bro,
before.
that's badass!
So you need an engine to be this
so
efficient to be able
cool.
to do non-stop trans-Pacific. So if you just took like a Concorde, for instance, and re-engined it with this sort of architecture, you get about 61% more range, which is pretty significant. So Concorde could do more than the Atlantic. This can do the Pacific. When I was 13, I started building model planes, and something that was like really clear in that world was the gap between what was technically possible and what was, I guess, readily available. Where like it was a really wide gap, and this was like deeply annoying to me. And it was just like obvious that you could have an aircraft company making these new, better airplanes. And so that was always in the back of my mind. The stuff that we had with model aircraft, these electric motors, they were just way, way better. But the batteries sucked. That's always, and still is a limiting factor. But there was something to this of like how much better electric systems could be. So over time, as I sort of like advanced as a pilot, aircraft builder, got to flying jets, I had built up like enough tree of knowledge that I had on how to build and design things. I could plot a path of how to really solve a bunch of these issues that we had in aerospace, specifically sort of more on the private jet end of things.
We started with the engine first. I mean, planes are built around engines. It's what made powered flight possible. And so it was only from having an insight on a new way to advance supersonic propulsion that I consider like actually making a supersonic plane. So the first one was I realized a new way to make the turboelectric adaptive engine.
I like
And
that.
that solves efficiency, like technical limitations, but it doesn't fully solve the economic challenge. You know, you're still going to consume a lot more energy as you go faster. And so the next part of this came in from rockets. You know, they're all switching from kerosene-based fuels, which is, you know, essentially just jet fuel, to methane-based fuel. So, you know, rockets use methalox, And this is actually just, this is LNG, and interestingly, LNG is a tenth the price of jet fuel.
One advantage we have in starting on our project now is that we don't have a ton of like kind of the legacy history. So when you think about modern day electronics, we have all these cool like gadgets. Your iPhone is an amazing piece of technology, and we're basically planning to leverage that level of technology in our plane. So things like when you talk in plane world, people are like, "Oh, is the engine controller like actually fully digitally controlled?"
No
which is
way.
kind of like almost an
No way. Dude, who knows what that was? Whoa, hold up. I usually don't stop the video and talk over it. You guys know what that is? Anyone? That's a Tesla battery pack. That's a Tesla battery pack. That's what that is. There's no T in pack. It's a Tesla battery pack. Yo, that's awesome. Yes, that's so cool. Yeah, these guys hot wired a jet engine to a Tesla battery pack. That's
talk in plane world. People are like, "Oh,
that's pretty good, man. That's pretty cool." Dude, I swear if their hybrid motors are Tesla motors, that'd be pretty sick, dude.
Was your engine controller like actually fully digitally controlled, which is kind of like almost an insane question in like 2024. So kind of from the ground up building for modern electronics and like modern software practices.
We're able to utilize like a bunch of the electric motor technology that's getting developed for the EV.
Oh, tell me they're using a plaid motor. A plaid motor would be perfect for this. Okay, all right. Shut up. They are, Baron. They are. Okay, all right. Frick off. Listen, plaid motors would be it's really good for this. The reason why is those plaid motors, the windings. So like, okay, all right, let me rewind a little bit. How does an electric motor work? All right, you have a field, right? And then you have an electromagnet, okay? The field is on the outside, the electromagnet is on the inside. The electromagnet alternates north and south poles, right? And that gets rotation. And if you flip it fast enough, it'll spin around its field, right? Now, here's a problem with that. So electric motors basically have one moving part. It's just the shaft moving inside of the housing, right? Here's the thing. This is what Tesla solved with the Plaid and Cybertruck and the Tesla Semi for what it's worth. Electric motors are only good to a certain RPM. They really are they're only good to a certain RPM before your copper windings on your electromagnet start basically delaminating because of centrifugal force. They'll start separating apart and then they'll eventually just come apart like a balloon popping, right? Tesla's solution to that problem was to take the same type of technology that they used to make composite overwrap pressure vessels on Falcon 9 and wrap the windings on the electric motor. They wrap the windings on the electromagnet on the electric motor. That allows the electric motor to spin insanely fast and you don't have to worry about it coming apart. The carbon fiber, when it spins, it's going to push out on the carbon fiber, and that carbon fiber will actually get stronger as it pushes out further and prevent it from moving. But that carbon fiber also had to be thin enough to be able to still allow the magnetism to go through it, right? That's the genius behind it. Whoever came up with that is not of this earth. It's wild. So why would that be good in this particular application? Well, the Plaid motors can spin at ridiculously high RPM because of the windings on the electromagnet. They can spin ridiculously fast. That's perfect for a jet engine. Jet engines spin at extremely high RPMs. So that's perfect. That's perfect for a turbofan or a compressor. That's really smart. That's a really good idea. Bro, these guys are just freaking parting out a freaking Plaid Tesla and using it to make a hybrid jet engine. That's badass, dude. That's super cool.
EV market, but also for like the EV racing market, right? So the coolest part is we have these wild like electric motors right there that are like carbon fiber. They're super lightweight, they're super high performance, and they're like really compact. And so it's kind of this perfect time to be able to use that.
Bro, that guy if I ever meet that guy, he's instantly becoming my friend because that guy's getting hype about it because it's friggin' cool, because it is cool, all right?
We first, came out showing what we call now our Gen 1 engine, and that was proving the especially new part of what we're doing of using electric compression for supersonic propulsion. Those generating roughly Mach 3 exhaust velocities. That was the first thing. We then built what we call our Gen 2. That was to show, all right, this is behaving like a very efficient turbofan cycle, electric fan cycle. Now the thing that we're demoing is Gen 3. This is the first to marry those two things. It's the efficient supersonic high-speed cycle combined with the high-efficiency subsonic cycle into a single engine where it's fully demonstrated the adaptive capability in one system.
Next engine is basically the first kind of engine that size that could actually be useful on a plane.
Yeah, so you heard
it's
that
like
too.
a full thing. We're going to be trying to test fire and basically demonstrate the technology, and presumably learn a lot along the way.
Today is the first day we're going to be going for hot fire on that engine, demonstrating that full performance.
What's it like being here after years and decades for you of imagining a system like this?
Oh, I'm not too sentimental. I just want it to work.
Go time?
Another test.
Look at that control
We're
board.
gonna
Did you see that?
staircase up with the fuel valve, and we're not going to light the igniter at all. We're not gonna
Oh yeah,
put any igniter.
you need full flow on that
Yes.
one. Yeah.
So we're going to do a cold flow where we sweep through a bunch of different conditions, then have a better sense of how much to open that servo valve.
And you want to do a same sequence this time of have the igniter go once it's already flowing.
Yeah, we are gearing up for another test, trying it at slightly different fuel ramp profile. We're going to throttle up a bit more slowly and hit a couple different set points that we think are going to be lower power, but perhaps a bit easier to ignite. So we'll see.
That's pretty neat. Yeah, yeah, that's pretty cool.
Making some racket. Neighbors are not gonna be excited about it.
Word.
Nice. Hey. Congrats. Yes. Oh. No?
You hit the manual board? Yeah.
This is the burner.
It's always kind of exciting to see that initial didn't blow up. So we're at a good starting point. Sometimes, I don't know, there was bets being placed, so it's always nerve-wracking. I don't want to lose a bet. I don't have a lot of money, so I can't really lose. I gotta win these bets.
Everything that we're doing is predicated on the functionality of this engine, that it is going to be the new capable thing that it is. And that was the very first thing that we set out to prove, and what we've done and what we're demonstrating now. So now we can go on to the work of building a relatively conventional supersonic aircraft, as much as that can be a thing, because the engine is what had to change. Really, now the path ahead is first prove the engine, and when we build this aircraft, build an unmanned aircraft. Then once we get familiar with this technology, we're actually out there, flying it, a thing much like we'll eventually have people. Then we can go through the very long process of going through FAA certification. I would say we expect to probably be flying something at most 2 years to get to this supersonic flight demonstrator, and our version of this is going to be pretty big and substantial. I'm going to be flying an experimental one of these certainly inside of 5 years. When first paying passengers can be going on something like this, probably more in the range of 7 to 10 years out. So for when we get to these first passenger flights, we're still going to be small. This is going to be like tens of flights per day, maybe. Then you go start to go up the ladder of, okay, we get a little bit bigger. We go for people paying first class. Now you're maybe in the hundreds of flights per day. Then eventually you scale this up to where you're doing thousands of flights per day. That's the ultimate destination, and you have to go bit by bit.
Do you think we're kind of living through a new aviation renaissance with all the new companies in innovation? Not yet. We're close, but there hasn't really, I mean, I think this is the point of my company. Like, we haven't had a catalyst to really change this yet. But the future that we'll have really will be, it's the one that we're going to bring about. The accessibility, none of like flying at this scale. This isn't, you know, made for scalable really. It's like the jet level of flying, but made personal. And it's not this like elitist thing or something like that. It's like everybody gets to have that.
I feel like so much of our existence is defined by sort of time separation. It's going to feel like there's just that much more of the world that is accessible to you.
Proceed as requested to the south run up beer area via Alpha.
Put it down on the hash marks, baby.
Next time we see you,
Nice.
we'll be breaking the sound barrier at our own airplane.
Cool. Dude, there was some... So, okay, what are we looking at here? Let me go back to where the guy was showing the diagrams. Dude, that's super cool, first of all. So, basically how this works is it's an APU. It's an AP. The jet. There are jet engines on it. The jet engines are working. Jet engines are working like an auxiliary power unit, and the auxiliary power unit is powering electric ducted fans. That's what's going on. That's what it's doing. Why? Why is that better? Well, the electric ducted fan is more. You can make more thrust with that thing, first of all, and you can make more thrust efficiently using an electric fan rather than using a jet engine. A jet engine is kind of brute forcing this, right? So think about it like a diesel hydraulic locomotive versus a diesel electric locomotive, or a diesel mechanical even. You're using the shaft horsepower from the diesel engine to power your drive, like basically how a modern diesel truck works or anything else. This is a jet electric hybrid. Now, once again, like with lightweight batteries, you can really make something that can go for extremely long periods of time. And like better yet, you can tap the APUs right off of your intakes. Which is what they did, I think, in this video here. That's what their concept design showed. That right there. Look. So they have two kind of regular jet engines right here. These are just garden variety things, right? But once again, those jet engines aren't designed to make thrust. They're auxiliary power units, or in this particular case, your primary power units, right? So these two jet engines are basically, they're more like a helicopter. Actually, it's a helicopter int. Why hasn't someone done this with helicopter int? Gonna make a couple phone calls after this stream, okay? Gotta make a couple phone calls. There's no way no one's thought of that. Imagine a combo electric motor swash plate. There's no way someone hasn't thought of this, Aqualex. There's not a chance in hell. That was too low-hanging fruit. Anyway, so these two jet engines work more like a helicopter engine in that they generate electrical power. See, they're connected to two generators right there. The generators will charge batteries, all right? And those batteries will turn electric fans, will turn basically a ducted fan right here. These are just electric ducted fans. There's no turbine here. The turbines are right there. Hold on, let me back it up. The design that he showed was actually super cool. Trying to find it. This. So let me take a look. Let me see if I'm understanding this right. So they have a jet engine here that runs off liquefied natural gas, right? And that is connected. Where is this? Where are they getting the intake air from? Let's just say they're getting the intake air from the tap off like we thought. This LNG APU is powering an electric motor, and that electric motor goes to two more electric motors that are inside of this shaft right here. These ones are a turbine and a compressor. They're on electric motors. Actually, I mean, with this type of design, you wouldn't need a turbine at all. The turbine's already there. You just need compressors. So you could operate your compressors at variable RPMs. That's smart, man. That's really smart. That's a really good idea. Like, yeah, Bob, I got it. I was just wondering, like, yeah, they those guys, that's a two-stage axial compressor right there. That's what it is. There's no turbine. The turbine is up here. That is dude, this is a turbo pump. It's basically a turbo pump from a rocket engine, very similar. I mean, it's more like just the turbine housing from a jet engine, but it's running off LNG and it's a gas generator. Interestingly enough, it has a gas generator. It doesn't have a combustor. That's more like rockets than anything. But the turbine is connected to a shaft, and on a rocket engine, this is a fuel pump. So turbo pump. This is a turbo generator. Yeah, see? Yeah, turbo generator. So it's a jet engine that's basically generating power. And that power is conveyed to two engines here. This energy transfer is super efficient. Jet engines are great at generating electric power. They're really, really good at it. They're really good at generating a lot of electrical current over a very long period of time because jet engines are very fuel efficient. They're very fuel efficient for the energy that they're consuming versus energy put out, right? I mean, don't get me wrong, thermodynamics still applies here, but basically hybridizing the compressor is super smart. That's really smart. And if you tapped an oxidizer line, post compressor, you have a tap off going back to your gas generator. This will work. That's really smart. Why not use a motor generator setup instead of an entirely separate generator? I don't know. Can you post the link to this video? Sure, man. This is super cool. You're going to be more efficient doing this because your jet engine isn't doing all the work. Your electric motors are. Like I said, diesel electric locomotive versus a diesel mechanical. It's way more efficient. The issue I have there is there's now two engines to take care of, which means there's more that can break. Yeah, right. I have ideas. I have ideas. Yeah, the light bulb went off. Going through the FAA is going to be super fun. Yeah, it's fine. Flux product line, AXM. How much of one of those things cost? So, Bright, my idea is to take this and just put it right here. Why don't you just take that and put it right there? So, you know, it'll end up looking something like that. but hybrid. You guys, anybody out there want to make a turbo electric ramjet? Anybody? I mean, these guys are already doing it, and that's super cool. But also, you know, I mean, theirs probably does that. They've probably already thought of this to be 100% real, but yeah, that's super smart, dude. Clear out the garage. We're already good. They got plenty of space. We're ready to go. I mean, what does their website say? Hold up. Somebody said something. I want to see that. Their website says they integrate the ramjet. That's what they're doing. Yep. Okay. Yeah, it is. That's what's going on here. Okay. So, okay, first of all, that's what they're doing with this design. Second of all, yeah, I'm not sure I have anything to add because that's exactly how I would do this. Yeah. Yeah, they're building a turbo generator electric ramjet. That's gonna go really frigging fast. Yeah. You might want to read the description they wrote in their Y Combinator page. I don't know what Y Combinator is, but all right. Yeah. Yeah, Ian Brook. Yeah, dude. There. Okay, we should back off because that's, yeah. That's a cool idea. Unpause the video for a second. Sure.
Behaves just like a turbofan, and then what we're testing today for the first time is we're going to introduce fuel here in the combustor.
Oh, yeah. Okay.
And that allows the system to behave both as that turbofan cycle and then going past that to be the jet cycle. That combination of low speed and high speed capability and efficiency,
that's super smart,
increases
dude.
the range pretty dramatically over anything that's existed before. So you need an engine to be this efficient to be able
Read it again. It can launch payloads into orbit. Dude, you could go insanely fast with this motor.
to do nonstop trans-Pacific.
Yeah.
So if you just took like a Concorde, for instance, and re-engined it with this sort of architecture, you get about 61% more range, which is pretty significant. So Concorde could do more than the Atlantic.
This can do the Pacific.
Yeah. Yeah, it could also do it way faster. Yeah, okay. That's yeah, that's really cool, actually. That's really neat. I wonder how well that engine would operate at high altitude with a really cold environment. Well, water drop, that would really depend on your intake geometry. Their intake geometry and their design is a conic or a cone intake. I mean, which is basically kind of garden variety. Your intake is really going to matter at higher speeds. Check out the Y Combinator page again. Okay. All right. I will look at it because you're insistent on it. That's super cool, dude. These guys did some pretty awesome work. That thing is 3D printed, by the way. That's laser sintered all day. Yeah, that jet's 3D printed. Oh, man, it's beautiful. Splines. Splines. Oh, yeah, look at those splines. Very nice. 24 splines. Nice. 24 spline axles. Pretty good. Pretty good. It could launch payloads into orbit. It's possible you could use this as a first stage. Yes, absolutely. Yeah. Oh! Oh, hello. Yeah, see, not only can it go across the Pacific, it can do it a lot faster. Yeah, this has it's got potential. Dude, this, and man, I saw you say it. This with 6 of these with compression lift. Imagine how much lighter an XB70 would be if you had this instead of the 6 what are those jet engines in there? They're the same engines as the Hustler, I forget. Scott Pozzi. Oh yeah. Single billet, Sandy. Yeah, you see that? It's not a J79, not in the XB70. Did I see that last image? I mean, did you see it on the stream? We can deliver 3.5 times more payload capacity by air launching a rocket at 800 meters a second. That also makes it 3.5 times cheaper than launching from the ground. I'll believe that when I see it. Yeah, no. 800 meters a second is less than 10% of the way. Nah, actually, it's about 10% of the way to orbit. So they said we could deliver 3.5 times more payload capacity by air launching a rocket. That's I'll believe that one when I see it. But also, really cool progress, dudes. Maybe if you start at 50,000 altitude. 50,000 is a fifth of the way to orbit by a height. Like, you need to be going 17,500 miles an hour, or about 7,600 meters a second. And you need to be 400 kilometers, or, well, you could probably get away with it at 120 kilometers that way. So 120 kilometers that way, and 7.6 kilometers a second that way. Speed. You need to go fast. 800 meters a second is nothing. That's nothing. First stages have way more delta V than that. The Tesla motor, though, is sick, Hellfish. That's super cool. That is really freaking cool. Launching small sats at the lowest cost possible. If they wanted to do it with small sats, Bill, what I would do with this is have a carrier plane and a solid rocket second stage, like in Tauri's or something. Yeah, you make a pretty good small sat launcher that way. But yeah, why would that exist with Starship? Well, like, what does that do with Starship? I mean, all right, dude, they got that. Last time the US bit, they playing around the engine. Yeah, Baron. Yeah. Yep. Can we try it in Kerbal sometime? I've been there, done that, dude. It's not a bad thing to have dissimilar architecture. This isn't dissimilar architecture. You're comparing a 747 to a Cessna 152, Hokey. I think this is great as an airliner, personally. This is an excellent idea for like something like Concorde or something. Hey Astro, what's up? Sorry to refer to this to why do this when you have Starship. Yeah, I got you. In that same logic, Rocket Lab is pointless now that there's Starship. Yeah, but with Neutron Mutter, you're moving more than just a small satellite into orbit. Rocket Lab themselves admitted to small sat high frequency launches not really being a good idea. Just putting it out there. Starliner's pointless now that we have Starship. Yeah, well, we'll see. Yeah, Tessa, there's that. Anyway, that's super cool. That's a super cool idea. I think that's really, really neat. I kind of want to take a look at their test stand here. Sure would like to get a look at some of your files. Yep. Just got a nice big propane tank hook up to that thing, boy. So this doesn't have the turbine attached. This doesn't have the turbo generator attachment. This is just running off battery power, if I'm looking at this right. All this is doing is testing the staged compressors and the afterburner, which is still cool. Like, don't get me wrong, that's still really neat because, well, hold on. Watch. It's really neat because instant thrust. Go. Yeah, instant thrust. That's pretty rad. This is a propane accessory, boy. Yep. That's exactly what it is, I tell you what. Is that mount extruded aluminum, Mutter? Yep, okay. How much electricity fuel is it using? Yes. I don't know what the specific consumption is. Looks like 80-20 extrusions. That motor is being held together with extruded aluminum. And you know what? I'm here for it. Crop that image, did we? That's pretty funny. This app's free, by the way. That's pretty good. Oh, that's pretty funny, man. Anyway. They estimate crossing the Pacific at supersonic on one take of gas. That's cheap LNG. That's insane. LNG for jet engines is... I mean, I agree with them fully on that one, Bob. Why we're not using LNG for just everything is kind of ridiculous. Like, okay, what do I mean? LNG you just basically pump out of the ground. Unless there's some petroleum experts out there that know a little bit more about this than me, you basically just pull LNG out of the ground. Am I like, you probably have to do something to it, but the point is that you're not the point is that you're not, so like with oil, you have to pump crude out of the ground and then you have to put the crude through a distillation tower and you distill it and then you can refine it from there, right? Phil Sloss's YouTube channel is amazing, Baron. Yeah, that was an instant subscription when I figured it out the other day. I saw it about a week ago. You have to cool it to liquefy it. Yeah, sure, right? But LNG is in gas form when it comes out of the ground. It has to be recompressed. It is also refined. Yeah. So long story short, it's a little bit simpler than making jet fuel. So Yeah, that it's a little bit simpler. It's cheaper. Like I use LNG to heat my house. Well, not LNG. It's just the gas line, but you get the idea. It turns out Hank Hill was right. Propane and propane accessories, boy. Actually, liquefied natural gas is methane, propane, and butane. And there's different actually formulas of LNG, guys, that have different ratios of methane, propane, and butane, depending on what you're doing. Some rockets use LNG, like Blue Origin. Everybody thinks that New Glenn is a methalox rocket. No, LNG. Yep. They're using mostly methane with a little sprinkle of butane and a little sprinkle of propane. Boy, I tell you what, boy, that dang old boy ain't right, man. Kick that dang old butt, man. Get. Hank, will you guys keep it down? I am trying to read an article on vintage Camaros, and I've been on the same page for about 30 minutes. Vulcan is LNG as well, Hokey. Yep. So is Terran 1 was LNG as well, but they ain't using that anymore. You could even replace LNG with methane generated from excess renewable power and CO2. Yeah, see? We can make horsepower, and we can also be environmentally conscious. That's a great idea. We should do that. This is a great idea. We should do this more. I like this plan. I'm happy to be a part of it. Let's do it. Okay, I have two more things for you here. Actually, I want to share this infographic, but I don't know who made it. Guys, who linked this? Fabricator, did you link this? Who? We got to give credit for this. Credit where credit is due. Where did this come from? Speaking of, relativity has been real quiet lately. No, this one wasn't you. Phil Sloss is amazing. His YouTube channel is fantastic. If you want to read about it. Yeah. It unsubscribed me from it. That's cool. Yeah, he talks about SLS and a bunch of other things. Phil Sloss is the resident kind of expert at NSF about NSF. He's been at NSF almost as long as I've been streaming, longer than I've been streaming, actually. But anyway, here. I'll put his YouTube channel in here. You guys go give him a subscription. Trust me, you won't be disappointed. They're jam-packed with information without the kookiness that I have. I prefer to jam-pack my streams with information and also confuse and annoy my viewers. Phil will just educate you. What? It's true. Anyway. I don't know who made this infographic, so I don't really want to share it, to be honest, but somebody was telling me it's called professionalism. Yeah. The channel that did the video we watched, S3, is also really cool. Right on. I come for the confusion and stay for the tech. Well, thank you for being honest. So these are all Falcon 9 Starlinks. There's Starlink 1.5 and then Starlink V2 -1, Starlink V2 2, and then Starlink V2 minis. And then there's Starlink V2s. That's Starship. That's what Starship is going to do. Can you put out similar content to this? What, to Phil? To what Phil Sloss does? I'll get back to you on that. Elon said Starship will launch Starlink V3. There probably won't be any use for full-sized V2. Crazy. Hey, Repairy.
Discovery,
3
go and
months,
throttle up.
not Repairy. Aren't V2s gigabit? They're not there yet, but they're close. We do have a Starlink launch in about 50 minutes. Yes. We like the spiciness, though. On stream, sure. Yeah, maybe. All right, so the last bit of space news that I got here is... this is coming from George Showers. This is a thread that we actually read about a little bit. Actually, when he posted this, Elon actually replied, and George actually replied to him too. This is about on-orbit refueling, which I think is really cool. Fish, did you find the original? Yeah, okay. We got to give credit where credit is due because I showed that image. Following up with my Starlink discussion with Herbert Ong, I updated the assumption table with Starlink V2 Mini launched last week. I also got some infographics showing stack and scale options. Oh, okay, cool. That was a not an official infographic. Still cool though. Still cool. That's coming from Julian Villamason. Probably not saying that right. Sorry, Julian, if you ever see this. Nice infographic though. Anyway, this one's coming from George Sowers here. Dipfish, thank you for finding the original. Check it out. George Sowers was a experimental scientist at, that's probably not the right thing. It says ULA chief mad scientist. He was kind of one of the designers that helped come up with Vulcan, but he has since retired, and he now is a professor at the Colorado School of Mines. Mines, not mimes. Okay. Elon replied to it saying, orbital refilling is essential to getting serious tonnage to Mars and to the moon. And George replied to him with a cool graph. Yes, but it's also a game changer for geostationary satellites. Maneuver without regret. And lowers the cost of every mission beyond low Earth orbit. Refueling breaks the tyranny of the rocket equation. Yep, delta V equals... Yeah, VE natural log initial mass over final. Yeah, he's using exhaust velocity in that delta V equation. You could use gravity and specific impulse too, but VE is probably a better way to do it now that I'm really thinking about it. So check it out. This is your delta V. Your propellant mass. Yeah, see? 5 metric ton payload, 0.92 stage mass fraction. Using Hydrolox propellants. Look at your delta V from no refueling, right? Goes, about 9 kilometers a second. So that's just one carrier rocket. So that would be just one Starship by itself. Basically what we have now. All right? With one refuel, you basically double your delta V. The reason why is because the amount... Okay, so what is the tyranny of the rocket equation? What is he talking about here? What does this all mean? Okay, I have to remind myself that a lot of people that watch the stream don't necessarily play KSP. If you want to know how I know all this stuff, I have like 15,000 hours in Kerbal. I've played it every day for about 10 years straight on stream. Why am I not playing it right now? They never made a sequel to it. There's your reason. So, to get into low Earth orbit, all right, a little bit of a primer for what all this stuff means. To get into low Earth orbit, you need to understand how rockets' range is measured. The range on rockets, like how far it can go, is not measured in distance. That makes no sense. The reason, well, why? Why not measure in distance? Well, because in order to break Earth's gravity, you got to be going really fast. So velocity is the name of the game with rocket range. Specifically, change in velocity. That's what the rocket equation says, okay? So, breaking the tyranny of the rocket equation. The rocket equation is it's a mathematical equation that was invented by a Russian mathematician named Konstantin Tsiolkovsky. What the delta V equation basically says is the more fuel you have on your rocket and the less rocket you have on your rocket means your rocket can accelerate to a faster speed, right? If you have a rocket that weighs 1 ton and you have 100 tons of fuel, right? 1 ton rocket, 100 tons of fuel. The ratio of rocket to fuel, right? That's what it's saying. Less rocket you have on your rocket, more fuel you have on your rocket, you'll be able to accelerate further because you can use most of the mass of your vehicle as fuel, so you can go a very long distance or accelerate to a very high speed. The reason why it's measured in change in velocity is because the name of the game in orbital mechanics is speed. We have to break the pull of gravity. In order to do that, you got to go really fast. Got to be going 17,500 miles an hour, or about 28,000 kilometers an hour, depending on where you are, right? Depending on your altitude. So once again, if you can accelerate to orbital velocity, right, you're going to basically get stuck in space because, right, if you have enough fuel to get to 17,000 miles an hour, 17,500 miles an hour, you will stay in orbit until something perturbs you and you get pulled back down by gravitational precession or atmospheric perturbations. Gravitational perturbations or atmospheric perturbations, if you really want to know. That's the super cool way of calling it. Basically, there's an atmosphere in the way. If you don't go high enough around Earth, the atmosphere is still up there, albeit in trace amounts, so you'll create enough drag and you'll eventually come back down. That's called the decaying orbit. But the Earth also has a non-uniform gravitational pull, and that basically wobbles around on its axis, and that non-uniform gravitational pull can perturb an orbit called an orbital gravitational perturbation, which means gravity will eventually pull you in because it's not uniform. Earth's gravitational field isn't uniform. Yeah, not a lot of people know that. Neither is the moon, for what it's worth. There's a reason why one part of the moon is always facing towards Earth, because one side of the moon is dense. Why is it dense? It got hit with something really frigging big. The gray areas, the darker gray areas, the lunar basaltic lowlands on the moon are basically the result of heat generated from something hitting that thing. Yeah, maybe Earth? I don't know. Anyway, yeah, nothing's perfect up there. It's very, very janky. But anyway, back to delta V. So, you got to accelerate to a certain speed. Now, delta V is usually measured in feet per second. You don't really use miles an hour or kilometers an hour for that regard, like for that matter. You can I like using meters a second or feet per second, either one. I use meters a second the most because KSP. Now, that's where this gets involved here. Now, I said in order to get in orbit around Earth, you need to be going 7,600 meters a second, which is 27,000 kilometers an hour or 17,500 miles an hour. There's your measurements. That would be like I don't know, like 23,000 feet per second or something. That was rough math off the top of my head. Probably not exactly right. So now I know what you're looking at here. No refueling. With no refueling, it says about 10,000. What's that about? Right? What's going on here? Didn't you just say, well, if orbital velocity is 7,600, don't you need 7,600 meters a second? No, you do not. You need 9,000. You need anywhere between 9 and 10 kilometers a second delta V to get into low Earth orbit. Why? The frigging atmosphere is in the way. That's why. We're not in there's not a vacuum down here on the surface. There's an atmosphere in the way, and you're going to be susceptible to aerodynamic drag. So to get into space from the surface at sea level to a 120 kilometer circular orbit, you need at least 9,000 meters a second delta V. Now, why no refueling? Why does it say 10,000? Well, in the case of Starship or any other vehicle, you're going to need some fuel for deorbiting, which is, I'm assuming that's what they took into account here. Right? And gravity loss. Well, of course. Duh. So, now Now that you understand a little bit about orbital mechanics, you need to be going really freaking fast. Now, refueling really bucks this a lot. It bucks the rocket equation. So if you launch more fuel into space and you refuel something like what Starship is planning on doing, well, let's go back and look at Super Heavy here for a second, okay? Let's go to SpaceX's X page here. SpaceX's X page. And let's look. Let's go to staging. How fast are they going at staging? What's their, in rocketry, it's called staging velocity. 5,200 kilometers an hour. So 52.27 kph in meters a second. That's 1,451 meters a second staging velocity. 1,400, okay? Remember, Starship needs to be going 7,600 meters a second, and the whole system needs 9,000 meters a second to get into low Earth orbit. Their staging velocity was about 1,500 meters a second, give or take. 5,200.
Stage separation.
Right. Starship is going to basically accelerate for the remaining 22,000 kilometers an hour, right? These numbers are ridiculous. These numbers are hard to understand, right? Not that, but you don't really know how fast 5,300 kilometers an hour is until you kind of sit there and think about it for a second. There's nothing that we see in everyday life goes that quickly, right? So that means that Starship by itself, the upper stage, which does most of your acceleration in any rocket design, right? It does most of your acceleration. The first stage is designed to get you up there. Second stage is designed to get you to go fast, right? Ballpark this. How much delta V you think Starship has? Their staging velocity was 1,500 meters a second, give or take. You need 7,600, 9,000 meters a second delta V total, right? That means that Starship, fully fueled, has anywhere between it has almost enough to basically take off by itself and fly into space. We're talking about 6 kilometers a second here. 6,000 meters a second, 6,500 meters a second, somewhere in there. That's rough napkin math off streamer brain, so just that's probably wrong. But think about this for a second. So think about this for a second. You basically have a Starship that more or less has empty propellant tanks on orbit, and you fill that Starship back up. Look at the difference. And keep in mind, this is with hydrolocks. This isn't exactly the same, but it's a similar idea. Like Elon and George Sowers basically agree on this, and them two are pretty smart. They're pretty smart people. Yeah. I'll get to that in a second, username. So, let me just put it to you like this. You need 9,000 meters a second to get to low Earth orbit, okay? If you have something sitting in low Earth orbit, you know, the Starship that you refueled, what do we think Starship has 7,000 meters a second delta V. It depends on payload mass, obviously, right? Less rocket on your rocket, more fuel on your rocket. It depends on what payload you're moving, obviously. But just kind of speaking generally, right, with basically, let's say a boilerplate payload mass, right? 100 tons. Starship has 6,500 meters a second. That's enough to get to the moon and back. No problem. Like, just go to the moon, just land, and then come back. Actually, you could pretty much go to the moon and land. The coming back part might be a little finicky. But the idea here, the point that I'm trying to make, all right, is that once you're in low Earth orbit, if we could just take Starship and Super Heavy, get it into low Earth orbit by itself, Starship could get to Pluto, no problem. Orbital refueling basically bucks the rocket equation, being able to refuel on orbit, because now you don't have to pay for rocket and fuel to get up there, right? And go wherever. You can refuel on orbit, right? And you can refuel on a ship that already has payload up there. And in doing that, you basically double or even triple or even quadruple your fueling, right? Like, look at just what one refueling thing will do. Is that nuts? That's crazy. This is with, keep in mind, this is 5 metric ton payload with you're using hydrolox, so these lines would be a little bit different because SpaceX is using straight methane. But exactly, Fish. For the uninitiated, guys, getting out of the grav well is like 90% of the way to anywhere when we're talking about rocket science. When you're talking about range for rockets. The reason why, like I said, you need 9,000 meters a second to get into orbit. If you're in orbit and have 9,000 meters a second delta V, you can go anywhere in the solar system easily. Like, easily. We're not even like it's going to take a long period of time. We're talking about if you're in the transfer window with Mars, we're talking Mars in 3 months. Maybe 2. The moon, go whenever. Go when it comes over the horizon. Kerbal players know. Oh yeah, easy. This is why, you know, if you guys have watched... You watch my reaction to that booster landing, right? We are on the precipice here for, and I'm not trying to sound really dramatic, but we're on the precipice of being able to actually do this. And if we can do this, the avenues to the moon, the avenues to Mars, the avenues to Venus, I don't know why you'd want to go there, but maybe there's Tabana gas and we can make Cloud City on Venus. Where's Lando at? That was a little bit of an old joke. It's an older joke, sir, but it checks out. You're halfway to anywhere. You're at 90% of the way to anywhere. This is basically in-flight refueling for airplanes, but with rockets. You can quadruple the range of anything. And it's such a big pain in the butt with the delta V equation, because the delta V equation, like any other physics equation, is a huge, huge pain in the butt. Anybody that knows anything about thermodynamics and in physics that's watching this stream, you know exactly what I'm talking about. You don't really ever win. You just kind of do good enough for what you're trying to do. You're never going to get 100% back. Like thermodynamics is like that. Energy transfer and stuff, man. I always say that spaceflight is like playing Tetris. You really don't win. You just kind of get better at it every time. And hopefully you don't lose. Takes a lot of practice. So Venus is actually easier to live on if you're not stuck to the idea of landing on the surface. I'll take my chances on Mars, dude. You can go live on Venus. Got to make sure there are no blue and black alien jellyfish on Venus doing things. That's true. That's true. That's a good point. So that's why landing that booster was such a freaking big deal. And speaking of boosters, here, let's check in on our buddies over at Starbase Live. Oh, look. Booster 13's on the chopsticks. With on-orbit refueling, would gravity-assisted trajectories be a thing of the past? Friend of monkeys, yeah. But if you gravity assist with refueling, you're gonna get places even faster, provided you don't do a razorback from the expanse and liquefy yourself. You know, that's actually a thing. Yeah, you don't want to do that. Anyway. Yeah, they just actually, right as I said that, they lowered the stupid thing. See? Something's wrong. It's coming back down. Quick last. What would be more cost effective? Launching initially with enough fuel to get to orbit and be empty, then refuel? Or launch completely full, then topping off in space with a second launch delivery. Tara, the topping off usually isn't a thing, dude. Like, no, I know that on-orbit refueling isn't like that. Like, dude, if you're engineering a rocket that's basically going to brute force up there and basically get up to space with like 50% left in the tank, first of all, you've made something as big as Sea Dragon. Second of all, yeah, I mean, any benefit would be good, but I just don't think we're capable of building a rocket that big. You know, I don't think we're there yet. Could it be done? Sure. Should it be done? Oh, yeah. Topping off would be fine. The more fuel you can get up there, the better. Yeah, Repairy, for sure. Can we launch Dragonfly on Starship? Yuri, I'm in, dude. Let's do it. I mean, if that program ever gets off the ground, figuratively and actually. It's mad how it's been 9 days since they caught a booster. Yep, they did raise it a little bit, but guess a date for Flight 6 right now, November 11th. I'll actually cry if Dragonfly gets canceled. I'm still looking forward to that one. Yeah, this NASA administration really likes to do that, Mini B. And it, I'm sorry, I've been patient with being very kind of, I've been patient basically as long as I've been covering space news. So I've been kind of speaking about space and talking about space for the better part of a decade. My patience ran out with Viper. Yeah. The Artemis thing pissed me off. My patience ran out with them with Viper. And laying off 800 people at JPL because, you know, it's impossible to get canned from a government job, but yet, you know, we can just lay off 800, like, super smart scientists from JPL. I'm sure that won't have repercussions on your labor force. I'm sure that'll be fine. Yeah, that pissed me off a little bit. The Artemis delays really were not the coolest thing I heard. And then Viper was the last straw. Somebody at NASA actually said, let's launch a block of concrete to the moon rather than launching the rover that we've finished because it's too expensive. You heard that right. That's when EJ blew a gasket. I'm like, nope. I've given you guys the benefit of the doubt for a decade. No, I'm done with that. You think that's hyperbole. That's not hyperbole. NASA was worried about funding overlap for their Viper program. What's Viper? Viper is a prospecting rover that's going to look for water ice on the moon in preparation for Artemis missions. It'd be pretty wise to know where those are before you go decide to make a moon base. So NASA they finished all the testing for it and had a fully completed rover. And then they said, it's going to cost too much to ship this thing up and put it on a launch vehicle. So we're canceling it. And Congress said, wait, you're doing what? Excuse me? And NASA said, we're worried about this pulling funding from other programs. We're worried about what's called funding overlap. So the best solution is to still launch the mission, not with our completed rover, but still launch the mission with a block of steel in place of the rover instead, because we'll save money that way. Do you see why that blew a gasket for your boy? I'm not, yeah, nope. There's a reason why I've been a little spicy over the past couple of space news, over the past couple of months. If you look at prior space news, I tend to keep my cool. Like, if you look at a space news from like 3 to 4 years ago, I tend to be very cool, very kind of like Phil Sloss. No, gloves are off. I'm pissed. Yeah, no, I think about that every day. Launch a block of steel. we're going to save money this way. Oh, you're going to save money that way. So when you go to land on the moon, you're not going to know where the ice is that you need to live on the moon. And what are you going to do to save money then? What's going to be the excuse then? How are you going to save money? That's what you're all about, right? Because, you know, NASA, you look up NASA's founding documents, like what NASA's mission statement is, and saving money is clearly at the top of that list, because that's, you know, that's good. Anyway. So, yeah, that's why I've been super gung-ho on Starship lately, and why I've been trying to give NASA the benefit of the doubt as much as humanly possible. It's gotten increasingly difficult. I kind of threw in the towel after Viper. Hey, nice haircut. Thank you, sir. Up, just in time, baby. Oh, yeah. They'll save money by not going. Yeah, Toothless, there's a very good reason why I don't think that's a valid excuse, and why we as taxpayers, especially after spending over $500 million to make Viper and test it, think that, yeah, you shouldn't be happy about that. You should be very pissed. You don't live on the moon. I don't see a world of NASA doing that anytime soon. I hope SpaceX figure it out. Yeah, exactly. Exactly, Space Plasma. Yeah, exactly. Exactly. That's exactly what I'm trying to say. How can you say that you're saving money when you're... See what I mean? That's the dumbest I've ever heard in my life. Like, you're NASA. You're not supposed to be this fucking stupid. Like, how? What? That's like having a luggage combination of 1, 2, 3, 4, 5. It's the kind of thing an idiot would put on his luggage. Sorry for yelling. Yeah, Andrew. Just instead of launching a metal box, just launch a metal box with boots in it so you could say you put boots on the ground at least. Stop guessing my combination. Stop giving my code away. What? I don't know what they're doing. They're doing something. I'm sure on some planet what NASA is doing is very impressive, but their weak link is this is Earth. You were close to my Wi-Fi password. Sorry. Note to self, change luggage combination. All right, okay. Thanks, Russell. I try to make it fun while also, like, if I'm getting salty, I try to make fun of myself or put a joke in there, because if I don't, I'm going to get pissed. I'm going to get pissed, and you don't want your boy getting pissed. All right? It wouldn't be pretty for anybody. I'm sure somebody would find it funny, though. The new code is 54321. Good call. Just Space, as someone on the inside, it doesn't make sense to us either. NASA seriously needs to change, and change soon. SLS is cannibalizing its budget, leading to serious exploration programs getting canceled. I'm hoping something gets changed with the new administrator in November. Just Space, you ever see the end of Mr. Deeds when Emilio gets all that money? And he is proven as the sole proprietor of Deeds Incorporated. What does he do? Do you remember? Do you ever see the end of that movie? Oh, you, sir. You are fired. You are fired. You are fired. Oh, you, sir. You are definitely fired. You're fired. Mr. Cedar, you are fired. Yeah. Oh, yeah. That would be me. In NSF, not NSF. NSF's cool. In NASA headquarters, they'd be like, "You're fired. You are fired. Oh, you, sir. You are definitely fired." And Bill would be like, "Well, what about me?" And I'd be like, "You stay. But tomorrow, you let me change your socks." Okay. Starlink is scrubbed. Damn. Oh, well. What are you gonna do? What are you gonna do? Feels weird, man. It would happen exactly like that. You are fired. Mr. Cedar, you are fired. Are you covering NS27 tomorrow? I will be here. Founded. Budget law says that because Viper went way too over budget too many times, they were under a termination review for the whole program. Yeah, I know. Yeah, and then you got 98% of the way there and exceeded your termination budget. Whoever comes up with termination budget rules, Arsenal, needs to be kicked in the scrotum repeatedly. Yeah, how about that? How about that? What do you think about that? Huh? Boom! There it is. Look at this freaking booster. Look at this booster. You see those engines? 33 engines. You see the booster come down, it comes lands with 10 out of 10 engines. 10 out of 10. 10 shut off, 3 land. Boom. Bam. What? Stop looking at me. Why are you booing me? I'm right. Yeah. What are you, a freaking world traveler? Yeah, you blend. Yeah, you blend. Well, you stick out like a sore thumb around here. But really, we need just a second SpaceX out there. SpaceX getting monopoly will end up with it becoming the next old space down the line. Yeah, Just Space. Okay, all right. You work in the industry. You're not a moron. Did I not say this 6 years ago? Did I not say this? I said this. Like, I'm not trying to toot my own horn here, bro. I've been saying this for years. Sounds like we would have enough fire at NASA HQ to get it to orbit, possibly the moon. Well, it would depend on how fast that fire is going, Andrew. It's all about exhaust velocity, all right? But yes. Absolutely, you did, and I was watching. Thank you! The frick! Does it feel like I'm yelling into the damn void? Is that a NASA-specific law or a Congress thing? I mean, get 90% of the way there and cancel. It sounds like a natural consequence of NASA as a jobs program mantra we've been... Well, deadlines. Deadlines and accountability fix that problem, Arsenal. You know who's in charge of making sure that these programs don't do stuff like this? Well, first of all, your contract structuring for an experimental developmental probe probably shouldn't be fixed because that's the dumbest thing I've ever heard. You'd need a cost-plus contracting structure. And if you have a cost-plus contracting structure, it needs to be cost-plus incentive. Cost-plus is not a bad way to do contracts if you have no idea how to do something. Funding stuff, especially rovers and stuff that you've never done before, trying new things, funding that on fixed price is the reason why this bullcrap happens. So what's the deal? If you fund stuff at a cost plus incentive, basically get it done by this date with good schedule milestones, get it done by this date, and you get a huge bonus, that jobs program trend gets bucked completely. And the more integrated your program is, the easier it'll be to weed out this jobs program nonsense. Okay? The way it's set up right now is incentivizing waste, which is stupid. And I'm not talking about anything else. I'm talking about NASA. I can't speak to any other government agencies. Don't read too much into this. I'm talking about NASA. You need to have deadlines. Okay, so where would you discern a Viper deadline? Oh, I don't know, sometime before Artemis 3. But here's the thing. Viper can't scale effectively if you don't know when people are going to return to the moon, right? You want to get Viper there before Artemis 3. When's Artemis 3 launching? I don't know. You could ask NASA. They probably wouldn't give you a straight answer. They don't know. You see the problem here? That's the problem. That's it right there. There's no accountability at NASA. There's nothing. There's no incentive to get anything done, and there's no accountability to get anything done because there's no deadlines. What makes NASA work? We choose to go to the moon in this decade. Those last 3 words, very important. NASA needs a deadline and a goal. You set a deadline and a goal with manageable stakeholder expectations, albeit even a little bold, they will get stuff done. It galvanizes the system to work correctly. We saw this happen when the last president said we're going back to the moon in 2024. You saw the whole system start to work. And then that ship sailed, and look what we have now. Just JPL getting gutted, Viper getting canceled, Artemis 2 getting pushed back because they can't engineer a damn heat shield correctly. See what I'm talking about? Weird, huh? Ironically, they figured out that they couldn't get the heat shield done, like they had delamination on their heat shield. Ironically, they figured that out because of the system started galvanizing in that direction towards getting stuff done. Can you imagine if the last president didn't say we're going back to the moon in 2024? Artemis 1 would have launched now. And if it launched now, you can kiss going to the moon goodbye in this decade. Think about that for a second. And that's not me. I'm going to use an awesome word. That's not me postulating. Probably not even using that word in correct context. That's not me speculating about it either. That absolutely would have happened. Just like everything else. Real talk. How does a cost plus contract become incentivized to meet deadlines if the contractor can keep asking for more money and time? That second part, time. You get this done. You get this done by this year. You don't get it done by this year and this date. You don't get a bonus. You don't get your bonus. You don't get paid. Done. Shepard, tier 1 35-month resub. Thank you. Like I said, dude, you saw it happen. You saw it happen with Jim. Because Jim was willing to put foot to tail to get what his boss told him to do done. Dude, he fired the head of HEOMD. He fired Gerst. Like, you know, he said, my boss says that we need to get back to the moon in 2024. The NASA's chief engineer, Bill Gerstenmaier, said, no, that's not happening. He said, all right, you're fired. What? Minia's 66-month resub. Remember, there are two types of people in the world. Avoid them both until we meet again, Skeletor. I think SpaceX would build a moon base if NASA can't fund it. Kirok, we're approaching a point where I don't think SpaceX needs NASA capital. Viper is just sitting in storage doing nothing right now, Snake, yes. Accountability is huge, guys. That's something that's apparently out the window. It's out the window because there's no real... What's the goal of the Artemis program? Get to the moon, maybe, and then maybe get to Mars in the 2030s? No. That's not good enough, man. It's not good enough. It's not good enough. You need to set schedule milestones for this. Getting to the moon sometime in this decade is not good enough. That's not good enough to galvanize the system like what I'm talking about. Getting to the moon next year would be something to think about. Or getting into at this point, I mean, Artemis is kind of at this point. 2026, you need to retest Orion's heat shield. You really need to. Launch it on something else. Launch it on something else. Launch it on Falcon Heavy. Screw it. Do another EFT-1 mission like you did with Delta IV Heavy in 2014. You got to test that heat shield. That heat shield cannot fail. Which is interesting because it's Avcoat, which is exactly the same as the Apollo heat shield, and somehow this one doesn't. Somehow this one doesn't work. Interesting. Did you go through this? Ground systems could delay Artemis 2 launch. Bro, me taking a dump could delay Artemis 2 at this point, all right? Refurbishment of the mobile launcher. Okay. Yeah, okay. Yeah, refurbishment of the ML. It's going to take a long time, right? Yeah, I read the gist of that article. Hey, when did the last booster launch off this? Just asking for a friend. I don't know, but pick unrelated. We need to check on EJ's bowel movements. Bro, when I go, you've seen me eat. When I go to town, I go to town, all right? It's very possible that could be a thing. NASA got the heat shield on Wish. Bro, it's the Temu heat shield all day. Why is Mars more attractive than the moon, for example? Kirok, if you really want my honest opinion, and the booster 13 is over the OLM, by the way. Yeah, the thing that launched a booster like last week. like about 2 weeks ago, whatever. Anyway, yeah, they're building the second stack. They're building another one. I'm telling you guys, Flight 6 is going to happen a lot sooner than you think. EGS already ran out of margin from the 1-year Artemis 2 delay. Yeah, see, this running out of margin thing happens, Phil. You know what you do? Cancel the contract. Wipe your butt with it. Which is what NASA should have done with Bechtel 5 years ago. Or 3 years ago, excuse me. But I digest. So, Kirok, good example. Why is Mars so attractive? Why is Mars so more attractive than the moon, for example? I personally think we should go to the moon. I don't mind the premise for the Artemis program. Go and learn to do things on the moon so you can go to Mars. Now, here's your trade-offs. Mars, probably easier to actually have a base on than on the moon. Why is that? Mars has a lot more resources than the moon. For instance, Mars has CO2 in the atmosphere. There is some semblance of an atmosphere. It's kind of a pathetic excuse for an atmosphere. No, you're not taking your helmet off on Mars and breathing. The atmosphere is not oxygen, it's CO2 and nitrogen. And there's only trace amounts of it in the lower parts of the Martian terrain. So what we think is at the bottom of where oceans were on Mars at one point. So Mars is probably a little bit easier to live on, right? There's more resources on tap, so to speak. The moon is a gigantic dead rock up there. It's a little bit harder to live on the moon. You're gonna need to find water ice on the moon to live there, right? Here's the thing, though. Every 26 months, in an the transfer window opens up to Mars. Basically, you can only get to Mars when Earth and the moon, or Earth and Mars, are close to each other. That happens every 26 months, right? So even then, it's 3 months there, 3 months out, 26 months stay, 3 months back, right? So if you go to Mars, you're going for 2 years. Once you do the trans-Martian injection burn and leave Earth's orbit, you're not coming back. Full stop. You're not coming back. So Mars, despite being easier, potentially easier to settle on, right, is far away, right? So I don't think, however, like, I think going to the moon in the interim is a good idea. But here is the thing. I said the moon is harder to live and work on. My kind of logic behind this is that if you can build something that can go to the moon and you can live sustainably on the moon, everything that's on the moon is on Mars as well. So building a vehicle that's designed to go to Mars from the start, or an integrated spaceflight architecture that's basically the end goal is Mars, can make a pretty good sustainable lunar exploration program in the interim time. I think it would be better to do this before just making that next giant leap, nice, to Mars, right? Because if you can live sustainably on the moon, you can absolutely live sustainably on Mars. If you could figure out how to make a closed loop system and work on the moon, it'd be easier to do it on Mars. The problem is, you're not doing that. You're only doing that every 26 months. That's the reason why Elon wants to send 1,000 starships in one transfer window, potentially down the road. That's why he wants to send 1,000, because it's gonna take a fleet. You're not sending 3 guys in a capsule with a lander to Mars. That's not how that works. Unless you want to stay basically in a broom closet for 3 months, and then spend 26 months on basically a dead rock. Right? So building something that has the capability of going to Mars first and then using that to explore the moon is the right move. That's what SpaceX is doing. Fun fact. Fish, I love the streams in this community, but unfortunately I'm going to have to take a hiatus and focus on school. Twitch is way too distracting. School comes first, man. School comes first, dude. You have to do that. I mean, Fish, you want to do this? You want to do this stuff? You want to design stuff like this? Go to school. They don't hand out engineering degrees, you know, at the GED office. You know what I'm saying? Thanks for the answer. No problem, Kirok. I personally really like what SpaceX is doing, or a different side of the coin would be the rocket architecture behind the Constellation program, which is canceled. This rocket, Ares 1 and Ares 5 over here. So this guy and that guy. You use this to build gigantic vehicles in low Earth orbit and then use that to go to the moon and then use it to go to Mars after that. The Constellation is superior architecture if you're looking to make Mars and lunar architecture with a shuttle-derived vehicle. It's basically better than SLS in every single facet, but we chose not to do that. We chose not to do that because of the same nonsense that got Viper canceled. Somebody playing games with NASA. My funding deadline. Yeah, your funding deadlines. How the hell do you know how much it's going to cost to go to the moon? We did that 50 years ago. There's no way you can extrapolate a proper price from this. This is stupid. Anyway. I think what SpaceX is doing is right. If it wasn't going to be something like SpaceX, something like Constellation would be superior. Not superior to SpaceX. Would be a good way to do it too. Not superior. That was the wrong choice of words. Back to school to prove to Dad that I'm not a fool. Hey, Fish, are you still here? Real quick. Real quick, dude. Fish, are you still here? Or did we lose him? Did we lose him? Okay. 2 things. 1, I thought you said you were leaving. Yeah, I called you out in front of all these people. Okay, jokes aside. 2nd thing. Can you do me a favor, man? The favor isn't something that's too difficult. You said you're going to stop watching the stream to focus on school. I get that, and I encourage it. You should stop. You should click off of this stream if you have homework to do. Seriously, leave. Fish, stay for another 15 seconds. Do me a favor. When you're done with school, could you just pop in here and tell me that you finished school? You do that for me? Can you do that for me? Yeah, Space, you ain't kidding. I'll be 100%. You'll 100% be back to tell all you. Good. Now go. Now go. Get out of here. Leave my stream. Go. Go on, Chicago. Chicago! You're out of there. Go. You're gone. Go. Okay. Nice, Azanku. There you go. Sweet. Okay. Pritesh, what's up, man? EJ, don't you think it would be wise to build a cruise ship-sized vessel in lower lunar orbit rendezvous or lunar orbit instead of sending thousands of ships? Pritesh, going to the moon to get to Mars that would be like saying, I'm sitting in Warsaw, Poland, and I want to go to London, but I'm going to stop at Rome because it's quicker. That's not how that works. There's a mountain range in the way. Going to the moon is going to be more expensive. Earth orbit rendezvous would probably be a good idea, and you could. The interesting thing, dude, is that that's what they wanted to do with the space shuttle. The space shuttle was supposed to do that. Except not at the moon. The space shuttle was supposed to build gigantic transfer vehicles in low Earth orbit, and then we use those to go further. That was the whole idea. Now, you could do that with Starship. You could. You could use Starship to build bigger vehicles. Starship actually affords you the flexibility to do whatever. You could send the entire Starship if you want, or you could use it to build a bigger vehicle, space shuttle style, which is super cool. You could do either one. SpaceX is intent on sending thousands of ships, which I actually think is a good idea. The reason why I think it's a good idea is because if one ship breaks and they're all on a transfer, all you got to do is rendezvous with another ship, transfer people off, and then you're done. Or fix the problem with spare parts on the other ships. It's kind of like a swarm. Think like a Zerg Rush if you ever played StarCraft, minus the whole death thing. Can we build Aurora? Sure. Yeah, of course we could, Trey. We just gotta figure out dude, Delta V, man. We could build the Aurora. We could build the Pillar of Autumn, sure. All right, but if we don't have something that's explosive enough to move something like that, then what's the point? You made a really nice space station. Come on, you've seen some of those connecting flights. Oh, shut up. I think a swarm Pritesh is a good idea. I think that's the way that SpaceX is onto something with that. Dude, even the Constellation program was going to do that. They were going to send 3 or 4 transfer vehicles at once. Yeah. Actually, they were going to send a couple of transfer vehicles in the first transfer window and send a couple more in the second transfer window. That's what Constellation wanted to do. But even then, that's a good idea. Sending multiples, not just one big ship. Just because sending a bunch of smaller ships right now is probably the quickest way to get there. But that doesn't mean we wouldn't be able to do like a Star Trek and build a bigger ship sometime in the future. This is a good, viable avenue to get to the surface of Mars right now. Right? And I think that's why SpaceX chose it, because it's something that it's proverbial low-hanging fruit in space exploration. Don't get me wrong. Nothing is easy in this business. Nothing. In terms of tech nodes, if we master on-orbit refueling, on-orbit construction, and ISRU for fuel and life support, we could go live anywhere in the solar system. Bingo. SpaceX is going to nail one of those problems very soon. Does that make sense, dude? Another reason to go play Marathon, part of the backstory for the game involves the establishment of a Mars colony. And they had a bunch of cycler ships that went out on a regular basis to Mars to transfer supplies. Oh, you're making me want to play those. You thought the synchronized Falcon 9 landings were sweet? Imagine seeing 100+ starships land on Mars at the same time. Yeah, baby. Thoughts on Mars Direct? Cope. Constellation is a better idea, Just Space. Direct is okay. Zubrin has kind of gotten a little out there over the last couple of years. I think the war in Ukraine broke his mind. Like, I mean, or either that or I'm not looking at the situation correctly. I don't know. I don't know what's going on over there. That guy rarely posts anything about space anymore. But dude, I'm like super scared because like I don't want that to be me in like 20 years. Like, oh no. Because Zubrin was like, if you go back and look at him in the 90s, like it's kind of the same energy. I'm like, oh no, I don't want to be destined to be a nut bar. Crap. Oh no. You know. Starship is somewhat based on Mars Direct. Yeah, Mars Direct is not a bad idea. What the Mars Direct architecture came out of Robert Zubrin basically being pissed at NASA because they've had their head completely up their tail. And apparently, I mean, it took 10 years for me to lose my patience with them. Zubrin has been around since the Apollo program, so I don't know when he said these guys are idiots. It's run by morons. I think he figured that out in the 80s. So Direct came out of that architecture to basically use what we have to get to Mars. And that's kind of, in that same regard, that's kind of what SpaceX is doing. Only SpaceX is kind of making some new stuff too, but you get the idea. Just researching ways on how to make quick Mars missions for RSS KSP. Dude, the Constellation architecture, Yuri, is about as simple as you're going to get for Mars transfer architecture if you're using RSSRO. I learned so much here, taking notes. There you go, Trey. Pritesh, interesting. Definitely in the future. Around 2040 decade, hopefully with artificial gravity. Dude, oh, Pritesh, you're gonna love this, dude. Hold up. So, Constellation, the one that I'm saying like is a good idea. One of the ideas that came out of Constellation was building transfer vehicles. I told you that Constellation was going to send 2 or 3 transfer vehicles. Check this out. That's what they looked like. They're called Copernicus, right? Note that there's Copernicus B and Copernicus A, right? There's different variations of this. That thing would burn if it had been made. That thing would burn on a Mars transfer orbit, so trans-Martian injection. right? And then, if you notice, there's a thruster block at the front, and there's a thruster block at the back. It would have started spinning end over end, like this. So it would have basically been flying through space like that until you got near Mars, and then it would negate it out, and then it would do a slowdown burn, right? But it was supposed to flip end over end to not make artificial gravity. That's not the right way to say it. To induce an outward acceleration on the spacecraft to mimic the effects of gravity. That's the right way of saying it. But dude, that's what they wanted to do. Okay, all right. If Constellation didn't get canceled, not only if it didn't get canceled, if it didn't get canceled, and even if it was behind, let's say it would be as bad as SLS, and it would be that far behind. If we had not canceled it 15 years ago, we would at least be starting to make this right now. Like, that is the worst case scenario. We would be starting to make this right now. If Constellation basically got flat funded like SLS, we would at least be starting this right now. Just putting it out there. Spinning is indeed a good trick. Yep. What about aerobraking to get into Mars orbit? That would be fine, but these transfer vehicles were not built with a heat shield. However, somebody is working on something that definitely has one of those, Yuri.
Discovery, go at throttle up.
How much would a full starship filled with space food last, chat? Well, Kurok, it really depends. How many mouths are you feeding? Also, yeah. And Orion would have flown to the ISS dozens of times. They definitely wouldn't be having problems with its heat shield, that's for sure. Hard, though. Very little atmosphere. Aerobraking is all fine and dandy, Just Space, but if I was developing Martian architecture myself, I would do a braking burn. Yeah, a braking burn. I wouldn't plunge right into the atmosphere. And if you could, you'd aero brake it a couple of times. Don't go for the whole kit and caboodle right off the bat. Like a direct insertion to the Martian ground. At least circularize first. Or you could just aero brake and lower your paramartian. You know what I'm talking about. Not to be a SpaceX super fanboy, Ultra Stan, but with how good OLMB is probably going to be, so in hindsight, would NASA have been better off contracting SpaceX for ML2? Erudite, if it was me, if I had known that this was happening, and if it was me, look, I can understand because of COVID, the price going up to $600 million. So the original contract was granted in 2019 for $380 million. In 2021, Bechtel went back to NASA and said, yeah, it's going to cost about $600 million instead. So, okay, now we've doubled it. I can understand that because of COVID, supply lines, etc., etc. Bechtel went back to NASA in 2023 and said, haha, just kidding. It's actually going to cost $900 million. It would be at that point where I would tell them to go do something else. I'd be like, yeah, no. Yeah, you guys can go. You guys can go do whatever you do over there. That's when I would have been like, hey, if I was an NASA administrator, I would have gone to Elon. I'd be like, yo, Elon, build me a mobile launcher. You clearly can do it faster. Dude, the contract award for the original ML Just Space is ass. It's so bad. It just said deliver it in 2023, figure the rest of everything out. It is asking for extortion. Like, somebody at NASA headquarters looked at this and said, yep, this is good. We're going to get a mobile launcher in 2023 this way. Yeah, no, Glitched. I don't need to get any more pissed off about that. Anyway, Booster 13 is on the OLM, guys. And since Starlink scrubbed, surprise, it's scheduled for 5:47 p.m. tomorrow. Nice. Right during space news again. That'll probably get pushed back. Yeah, I think we'll stop space news. It's 9 o'clock. We got to go back over into Satisfactory. We got some work to do. So interesting thing on Booster 13, they didn't reinstall the alignment pins, did they? No, they didn't. Or did they? I don't see them there. Oh, no, they're there. I can't see, dude. Hold on. Let me back it up, see if we can get some daylight. I don't see them there. Unless I'm dumb. Very much a possibility. Oh, yep, nope, they're there. See them? Right there. Yep, got it. Yeah, they're there. See that? That's it. See the gap? Yeah, they definitely did. Cool. Thanks, chat. They did yesterday-ish. Yeah, it's weird being able to, you know, get launch pads reconfigured and ready to go for another rocket in like less than 2 weeks. That's very strange. It's, you know, that's an interesting capability, you know. According to NASA, that can't be done. No, it can. Guys, trust me, I don't like dumping on NASA like that. I really don't. But also, what the actual frick, dude? What the actual frick? Come on, man. Good talking to you. I gotta go, but probably eyeing a change soon. Oh, dude, that sucks. I'm sorry. Hey, you want me to just base? I know people. So you never finished your thought on those photos I sent you. Why do you think it looks bad? It looks like the cam is wiped, Sawyer. There's heat scoring on the cam lobes, indicative of not changing oil. Just base, is it really that bad, dude? It's bad, isn't it? Ross, screw this, dude. Let's start our own. Let's start our own damn startup, dude. You think I can pitch an idea? You think I could get VC? I think I could do that. I'm pretty good at pitching ideas. I'm pretty sure we could get the VC that we need. Yes, it's that bad. Oh, man. Personally, I would go for a landing burn on the top of Olympus Mons and then transit the equipment and personnel down with rovers. Sword, I wouldn't do that. I'd want to land in the Mariner Valley. Do the exact opposite of that. There's more atmosphere down there. You can use that to slow down. Just mention AI and VC will send money. Yeah. We could start the Constellation Company. We could bring back Constellation. Let me just put it to you like this, guys. If I did do that, if we did do it, I wouldn't be able to stream anymore. If I did that and we went down the VC aerospace route, that would be 100% my commitment all the time. Yeah, Ingenuber, exactly. What's this video, Bandit? Oh, sweet. Space Tours, a 360 camera for the Starship launch. That's awesome. I'll let you know and keep you updated. You're gonna try for SpaceX once you get your cover letter together. All right. When? You should use the word when. All right, Crustacean. Yeah, Shmamaron. Yeah. I'd do it too. I wouldn't even, to be honest with you guys, I would love to do it. I don't even know where to begin. Where do you begin? I've actually talked to Rocket Guy about this before. Like, and he has to his credit been like, no, you just got to start here, 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 and here. And I'm like, okay, cool. And then nothing ever comes of it. But we'll see. We'll see. All right. That's going to do it for Space News, guys. I'm going over back to Satisfactory. If you're on the YouTube side of things, the VOD will restart. I'm going to end the stream on YouTube. Not on the Twitch side of things. Just don't go anywhere. You'll see the title card for probably about 5 minutes. Well, what do you want to accomplish? I'm not saying here, Halengar. I'm not saying my ideas. Oh, I have ideas. Bro, you don't play as much Kerbal as I do and not have money shot ideas. You know what I'm saying? Oh, I got ideas. Don't you worry. Don't you worry. I'm not telling you what they are, though. Because, like I said, I have been fully immersed in thinking about spaceflight architectures for the better part of a decade, every day, for 8 hours at the very least, for the last 10 years. Oh, believe me, I have ideas. Do you need someone with a CDL? Sure, man. I got Ernark, though. Starlink did scrub. Anyway, here's the title card. That's going to do it for Space News. I hope you enjoyed it. Thank you for watching the whole video. If you're watching on the YouTube side of things, I appreciate it, especially if you're watching the VOD. Thank you. I got to get into a habit of saying like, comment, and subscribe, but god dang, do I hate doing that. But seriously, though, that does help. Yeah, 12, we'll think about it. Will it be like EJ and Ernok's Excellent Adventure? Yep. Your idea is just doing what Constellation was going to do. That would not be a good place to start, Hired. That would be a very bad place to start. Sell out. All right. See you guys. Once again, if you're on Twitch, don't go anywhere. I'll be right back.